Good morning to all.
Good morning, madam.
Good morning.
Good morning, madam.
Can you all see my screen?
Ma'am.
Yes, madam.
Yes, madam.
Okay. In last week, we were discuss about what is the database and the database management system and about history of the database and also the type of databases and we were discussed about database models such as hierarchical model, network model, relational model, and the entity relationship data model and the object oriented data model and so on. So if you have any doubt or any questions about last session, now it's time to raise your question. I will give you 5 minutes. You can raise your question from the last session. Until others join, you can ask or you can classify. Yeah, you can raise your question about last session if you have any doubt. If not, it is okay. No questions? Okay. If you don't have any questions, let's continue from entity relationship model. This is the session number 8. You can refer your textbook. Can you all hear me clearly?
Yes, madam.
Okay. Then let's start from this entity relationship model. Okay, in last week we were discussed about the basic things about this entity relationship model. So under the conceptual designing, we were discuss about the ER diagram. So the ER diagram is used to model the database in conceptual modeling. So let's discuss about the ER model components. So when we consider about this ER model, mostly we use ER diagram to model the database. So in this case, it is needed to identify the components available in this ER designing and the ER model. First of all, let's discuss about ER component. I think you have some experience and the familiarity with entities and attributes. In last week, we were discussed about these two things in ER model. So today we are going to discuss these things in detail. So the difference between this discussion from the last session is we are going to discuss about graphical depiction of the relationship among the entities as well as the ability to summarize the wealth of the information required to implement the successful designing. So these are the main differences from the last discussion. So when we consider about this ER model is based on the ER diagram. So this is the short form of this ER diagram, entity relationship diagram. So this is belongs for the conceptual modeling. So in the conceptual database, we use this ER diagram for the conceptual modeling. So this diagram represents the conceptual database as viewed by the end user. Okay, so this is represent the conceptual database as viewed by the end user. So these are the main three components available in the ER model as well as ER diagram. That means this ER diagram is the way that depict this ER model. So in this ER diagram, these are the main three attributes. The first one is entities, the second one is attributes, and the third one is relationships. So I think you have some idea about these entities. So what is an entity? Can someone answer my question? What is an entity? We already discussed about these entities and attributes. So what is an entity?
Person or things?
Yeah, person, place, thing can be categorized as the entity, which we are going to collect the data. Okay, so simply this entity represent a real world object. That means any place, anything, any person, anything. Okay, we can categorize as a entity. As an example, let's take this XYZ university. So this university is consist with students, then about classes and the teachers and the classrooms. So we can take these component as the entities of this XYZ university. Okay. So you can see when we consider about these students, this student represent a set of values, that means set of data set. So you can see when we consider about OUSL database or a OUSL student, you can see the level 1 students are there, level 2 students are there, level 3 students are there. Likewise, this student represent a group of data set. Okay, but we only use the single word to depict this entity. Okay, so when we consider about this ER model, actually it refers to the entity set, not a single entity occurrence. Okay, so this entity can be represented by using a rectangle with a capital letter. So you can use a noun to represent an entity. So it should be a singular, not in a plural form. So you can use this rectangular shape to depict the entity in ER modeling. No need to put your student numbers and the student numbers and the names into the chat. If you have any doubt or any confusion, you can drop a message for the chat. Okay, so you can when we consider about ER model, we can represent this entity by using a rectangle, and it should be a noun with the capital letters. So students. Is this correct? This is the entity students. Is this correct?
No, ma'am.
Why?
No, madam.
It is
It's in
plural.
plural.
It should be singular.
Yeah, this is in the plural form, but this should be in a singular form. You can write it like, student, like this. Okay, so this is about entity. Then let's move into the attributes. So when we consider about the attribute describe the characteristics of this entity. Attributes describe the characteristics of an entity. So when, as an example, let's take student. So what are the attributes of the student? So what are the attributes? What are the characteristics or attributes?
Student name, student ID.
Student ID. Okay, I then. Okay. Tell me another attribute. Student name, student ID.
The year.
Sorry?
The year.
Year. That means level. Or a date of birth.
Yes, madam. Level.
Level. Then the date of birth and the address. All these are attributes of the students, and we can use these attributes to identify the student. So in ER model, we can use oval shape to denote these attributes like this. Okay, so in this oval shape or oval, we can write the attributes name. So no need, so if you can write it in a capital letter, it is okay, not a rule, but in singular form, that is okay, but you practice to write it in capital letters. Okay, so when we consider about the student entity, this entity includes the student first name, then the last name, then the initials, and we can use this is STU. This is the shortened form of the students, like this, student address. So at that time, we can identify this name belongs to student entity. Okay, so as an example, let's take employee. In employee entity, we write it in capital form. So we can use EMP as a starting, then underscore EMP name, then EMP address, then the EMP ID. Likewise, to represent the attributes in the employee. So at that time, we can identify this entity, this attributes belongs to employee entity. There are some, no need to put your student numbers and the names into the chat. ඔයාලගේ නමයි student number එක, that means registration number එකයි දාන්න ඕනේ chat එකට. Okay, so this is about attributes. When we consider about attribute, it have a, that means these attributes have a domain. Domain of an attribute is the set of possible values of that attribute. As an example, let's take student. Student as an attribute as student name. So we can see in this class, yeah, Anjali. Then comma, likewise, this student attribute has a domain. Domain describes the set of possible values for that attribute. Okay. So when we consider about a GPA, GPA is one attribute from the student entity. So do you have any idea about the GPA? You are from level 1. Do you have any idea about this GPA? So this GPA calculate by using your subject weight and your result. So when we consider about GPA, the domain of this GPA is equal to 0 to 4. That means this is a numeric values and sorry. Okay. So GPA can be 0 up to 4. Okay. The maximum value of the GPA is equal to 4 and the minimum value is equal to 0. So we can use this range to define the GPA. So this is the domain of GPA attribute. Okay. So when we consider about sex, this is also an attribute. As example, let's take this is an attribute from the student entity. So we can take two possible values for this sex. The first one is female, then the second one is male. So this is the domain of this sex. Okay. Likewise, we can take the attributes according to the entities, and we can define a domain set for a domain means the range of values or a set of values that can be taken for the attributes. Okay. Okay.
Excuse me, madam.
Okay, go ahead.
When we consider the name,
Yeah.
what is the domain of that attribute?
You can use any domain. Yes, so you can use any name for the entity. There are some limited domains. This is
Yes.
example for limited domains. GPA only can be within 0 and 4. Sex only can be female and the
Okay.
male. But when we consider the entities like name and the address, and so yeah, at that time, no domain range. Okay, no, that means limited. In this case, limited domain. There are so many examples for unlimited domain. Okay,
Okay.
use any data set. Okay, when we consider about this ER diagram, in next week we are going to develop in an ER diagram. So in ER diagram, we only represent the attribute, but the domain of an attribute is not visible. That means in ER diagram, we only represent entity and their attributes, but domain set is not represented by using this ER diagram. But in database, we use, that means in database, we represent this domain. Okay. When we consider about attributes, attributes may share a domain. As an example, let's take this one. A student address and the professor address share the same domain of all possible address. In fact, the data dictionary may let a newly declared attribute inherit the characteristics of the existing attribute if the same attribute name is used. As an example, let's take these two entities, professor and the student. So the professor also has a entity as address. In the students, they also have a address. So the same entity, same attribute within two entities. No need to put your student numbers and the name. ඔයාලා ස්ටුඩන්ට් නම්බර් එකයි නේම් එකයි දාන්න පෙදුර මම හිතන්නේ ඔයාලා chat එකට මැසේජ් එකක් දාන්න. මොකක් හරි ප්‍රශ්නයක් අහනතර මම ආයෙ chat එක රිෆර් කරනවා. ඒ නිසා ඔයාලා chat එකට ඔයාලා ස්ටුඩන්ට් නම්බර් එකයි නේම් එකයි දාන්න ඕනේ නැහැ. Okay. Is it clear now? Do you have any questions up to now? This is about ER modeling. Now we already discussed about entities and the attributes. Do you have any questions from these entities and the attributes? Yes or no? Before moving to primary key. Do you have any questions?
No, madam.
Okay, then let's move into primary key. So before that, so when we consider about this primary key, in last week I think we were discussed about this primary key. This primary key is used to identify each and every record in uniquely. So as an example, you can see, let's take this course example. In this course, there are two attributes like course ID and the course name. So we can use course ID as C11, C12, then the C13. This is database designing, then the Java object-oriented concept likewise. So we can use one attribute from this entity to identify all the attributes in the given set. So such kind of attributes are known as primary key. So the primary key is a key which is used to identify each and every records in uniquely. Okay. What is this Q3E45? This is from the chat. What is this Q3E45? Is it a question? So I don't know. Okay, so that okay, entity is this is from, yeah, madam, could you please explain the entities and the attributes again? Entity is a real world object and it can be a place or a thing or a person, anything. But in ER diagram, we use a noun to denote these entities. So in ER diagram, you can use a rectangle to represent the entity, but entity should be in singular form like this, student. So you can use capital letters to represent the entity. Then the characteristics of this entity is known as attributes. So as an example, the student ID is an attribute, or a student ID is a characteristics of this student entity. So you can use oval shape to denote the attributes. So we can represent this attribute like this. This is up to you. You can use any name, but meaningful name to represent the attributes. Then this primary key. Primary key is a key which is used to identify each and every record in uniquely. So in ER diagram or ER modeling, we underline the primary key like this. Okay, so this is the cause. You can see the cause ID is the primary key of this cause entity. You can use underline sign to represent the primary key of this entity. Okay. Okay, let's take this one. I'm going to give you an example. Sorry, wait. Okay, this is about employee. Okay, it's difficult to write the whiteboard. You can see these are the attributes: employee address, then employee ID. So the employee name and the employee date of birth. So what is the entity of this diagram? So identify the entity.
Employee.
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 The attributes of this entity.
Employee name, employee ID, employee address, and
Employee date of birth.
date.
Date of birth denoted by using DOB, date of birth. So what is the primary key? What attributes can we choose as a primary key of this entity? Go through all the attributes. So what is the primary key?
Employee ID.
Yeah,
ID.
can
ID.
ID as the primary key of this entity. Okay, I think now you can identify the entity and the attributes and the primary key. Then let's discuss about the composite key. So it is very need to identify these things, and you need to keep these things in mind. When we consider about a composite key, the primary key is composed of only a single attribute. It is possible to have a primary key composed of more than one attribute. So in the primary key case, one attribute contribute to form the primary key. So there are some cases that two or more than, that means one or more than one attributes contributes to form a primary key. At that time, such kind of keys are known as composite key. You can see this is the course, and the course ID is the primary key of this course entity. So when we consider about department, there are two attributes, department number and the department name. These two attributes get together to form the primary key. Such kind of primary keys are known as composite key. That means the primary key is composed of one, or that means more than one attributes. This primary key is known as a composite key. Finally, when we consider about primary key, it is consist with one attribute. When consider about composite key, it is that means it is composed with more than one attribute. So the primary key can be divided into two category as a primary key and the composite key. In primary key scenario, one attribute contribute to form a primary key. In composite case, more than one attributes contribute to form primary key. Such kind of keys are known as composite key. Okay. Then about candidate key. Now we already discussed about primary key, then the composite key, then candidate key. So when we consider about one candidate key, this is the key that is qualified to be selected as the primary key, but not selected as the primary key. This is qualified to be a primary key, but not selected as the primary key. So if one entity has more than one attribute who can act as a primary key, then the designer should decide what attribute should be selected as the primary key. So there are some keys that are qualified to be selected, but not selected as the primary key. Such kind of keys are known as candidate key. Again, I'm going to take an example. You can see this is employee. So when we consider about this employee entity, so this should be in capital letter, employee entity. You can see employee ID, then NIC, then employee name, then the employee address, and the employee date of birth. So what is the primary key? What is the primary key of this employee entity?
ID, ma'am.
Yeah, you can choose ID as a primary key. Other one can choose NIC as the primary key. These two are unique. By using the NIC, you can identify each and every record in uniquely, as well as by using the employee ID, you can identify each and every records in uniquely. So you can choose one of these two attribute as primary key. This is up to you. That means the designer. This is up to designer. But when we consider about the employee ID as the primary key of this entity, definitely this should be a candidate key. So qualified to be a primary key, but not selected as the primary key. Okay. ඒ කියන්නේ අපි entity දෙකක් ගන්න. අපි ගත්තම table එකක් සමහර වෙලාවට අපිට entity දෙක තුනක් තියෙනවා. ඒ entity දෙක තුනම use කරලා අපිට එක එක records වෙන වෙනම අඳුර ගන්න පුළුවන්. ඒකට අපිට මේ entities දෙක තුනම primary key විදිහට use කරන්න පුළුවන් තනියම. හරිද? composite key එකක් විදිහට නෙවෙයි තනියම primary keys විදිහට use කරලා. හැබැයි primary key එක choose කරන්නේ designer. ඒ කියන්නේ දැන් database එක design කරන පුද්ගලයා තමයි ඒ primary key එක select කරගන්නේ. එතකොට මම employee ID එක select කරගත්තොත් primary key එක විදිහට මේ ER diagram එකේ තව කෙනෙක්ට පුළුවන් NIC එක primary key එකක් විදිහට select කරන්න. දැන් එකක් primary key එකක් විදිහට select කරලා පස්සේ අනිත් එක ඉතිරි වෙලා තමයි. හැබැයි යාට හැකියාව තියෙනවා primary key එකක් විදිහට add කරන්න. but designer යාව choose කරගත්තේ නැහැ. අන්න ඒ වගේ keys අපි කියනවා candidate key. candidate කියන්නේ මොකක්ද තරඟ වැදීමක් ඒ වගේ දෙයක් නේ. ඒ කියන්නේ qualified ඒත් යාව choose කරේ නැහැ. ඒ වගේ keys වලට තමයි අපි කියන්නේ candidate key කියලා. හරිද? Is it clear? There are two attributes qualified to become a primary key, but the designer choose only one attribute. At that time, other attributes is definitely a candidate key. Okay, in composite key, you can see. Okay, I'm going to explain it with the example. Wait. Okay, you can see this one. This is not a ER modeling, this is database modeling. I'm going to take an example from this one. In this case, as an example, let's take which one? This is a ID, something ID like this, and this is just like address. So you can see there are some attributes values, but when we consider about this like this, yeah, but example එක මතක් වෙන්නේ මොකද suitable ම කියලා. අපි දැන් මෙහෙම ගමුකෝ. data set එකක් තියෙනවා like this. Wait. Okay, let's take this one. Employee. In this case, you can take this employee ID EMP1, then EMP2, then EMP3, and the EMP4. Okay. So you can see this is NIC. Let's take 4 values for NIC. In this example, okay, like this, okay. You can see these are unique, no duplication values. So you can use this one or this one as a primary key. So when we talk about department, there are some background noise. There are some background noises. I'm going to mute you all. Okay. In this case, you can see department number, and as an example, you can see D001. There is another department as D001. This is belongs to computer science. This is belongs to computer studies. Okay. Then there is a 002 geography. Then 003 statistics. Then 004 social science. Okay, like this. Now you can see the same department number, but there are different names. So at that time, can we select this as a primary key? Can we select this as a primary key?
No.
No, we can't consider this as a primary key. But when we consider about this one and this one, these two, when we consider about these two attributes, so at that time, this one and this one, this one and this one, this one and this one, like this. So is it possible to take these two attributes as a primary key or a composite key?
Composite key we can use.
We can use these two attributes as the composite keys. ඒ කියන්නේ දැන් අපිට මෙතන ඔයාලට පේනවා මේ දෙන්නම primary key. මෙයාවත් uniquely identify කරන්න පුළුවන් වෙනම මෙයාවත් ඒ කියන්නේ මෙයාව choose කරලා අපිට එක එක record වෙනම use හොයාගන්න පුළුවන්. මෙයාවත් එහෙමයි. හැබැයි අපිට මෙයාව use කරලා හොයාගන්න බෑ. අපි මේ දෙන්නගේ එකතුවක් විදිහට ගත්තම අපිට හොයාගන්න පුළුවන්. So this is the computer science department and this is the computer studies department. So this kind of keys are known as a composite key. This kind of keys are known as the candidate key. So in candidate key, that key can identify each and every records uniquely. But when we consider about composite key, it is needed to have more than one attribute to identify each and every record uniquely. So this is the main difference between the candidate key and the composite key. Is it clear?
Yes, madam.
Yes, madam.
So when you are renaming your device or a Zoom device, can you use your student number, that means registration number or student number, then underscore and your name, okay? Rename like this. At that time, I can manage it, okay? Then in next day, you can rename your device with your student number, then the underscore and your name, okay? Like this. 305, then comma. Like this, you can rename your device, okay? Then I think now it is clear. Then let's move into, okay, this is another example. So this is, we are going to store in the OUSL student in a database. The entity and the entity set is a student. You can see this one. And there are 1, 2, 3, 4. How many attributes in this entity?
5.
5 attributes in this entity. So you can see NIC also can be taken as a primary key. So this is a candidate key, but the designer chose that student ID as the primary key. So this is the candidate key of this entity. So the NIC also can be treated as the primary key if the database designer or the user need to do so. Since here we are not using this NIC as a primary key, it is known as the candidate key. Okay, I think it was clear now. Then let's move into simple and the composite attributes. So when we consider about attributes, we can classify these attributes into two groups as a single, that means simple, and the composite. When we consider about the composite attribute, it is an attribute that can refer to us, that means that can be further subdivided into many attributes or additional attributes. So as an example, you can see this one. There are attributes can be divided into two categories as the simple attributes and the composite attributes. So when we consider about composite attribute, this is the attribute that can be further subdivided into additional attributes. As an example, let's take the address. So address can be subdivided into street and the city. When we consider about the phone number, you can subdivide the phone number into code and the exchange number. Likewise, there are some attributes that can be further subdivided into additional attributes. Such kind of attributes are known as composite attribute. Okay, I'm going to take an example. Wait. This is about student. So when we consider about a student, you can see student name. When we consider about a student name, you can see all the students have 3 or more parts, more than one part for your name. As an example, let's take initial. Let's take this one. So So this is the name. You can see initial, the first name and the last name. So your name can be subdivided into three parts as the initial, then first name and the last name. So student name can be subdivided into additional attributes like initial name, then the first name and the last name. So this kind of attributes is known as composite attributes. Is it clear?
Yes.
So it is very important to identify each and every case and the attributes types in the ER diagram when you are drawing ER diagram. Okay, then let's discuss about simple attributes. Before that, can you all hear me clearly?
Yes.
Ma'am, excuse me.
Go ahead.
In the previous example,
Yeah. This
we say that composite attribute means that student name only, not altogether, isn't it?
all together. This all together, but this is the attribute. You can divide it into other additional attributes. So all together, these are known as a composite attribute. So we can take this as a composite attribute. That means we can subdivide the student name into initials, then the last name and the middle name and the first name likewise. So this is the composite attribute. So these are the additional attribute that this can be subdivided. Okay.
Okay, ma'am.
Then simple attributes. So simple attribute cannot be subdivided. So you can see age. Can we subdivide this into another attributes? Age. Not the date of birth. I'm talking about age. Age is 25, then the 23 likewise a numeric value. Can we subdivide it into another attribute for additional attribute?
No.
Madam.
This is from the page number 51. Yeah, 51, 52, 53 likewise. So, okay. You can see a small diagram, that means entity and their attributes. So, identify the composite and the simple attribute. What is the simple attribute of this diagram?
Age.
Age. What is the composite attribute?
Name.
Name. Okay.
Ma'am, excuse me.
Okay.
Can we say that F name and L name as a single one?
Yeah, this is the simple attribute. Again, this is a simple attribute because this cannot be subdivided into another or additional attributes now. So this is a simple, but when we consider about this one, it is a composite attribute. Okay.
Okay.
Then let's discuss about single valued attribute. Okay. And the multi-value attribute. So a single value attribute can only a single value. That means can have only a single value. As an example, let's take student ID. So this is a single value. You can represent single value by using these attributes. Then the person NIC number and the manufacturer. In the manufacturer part, it can be taken as a serial number as a single value attribute. So when we consider about this kind of attributes, you can see we can have only a one value. So the attribute which can have only a one or a single value is known as a single value attribute. So the age is also a single value attribute because when we take any student from the student entity, each of them has a single value. Can you have two values for age?
No.
No. So it belongs to single value attribute. Then about multi-value attribute. Multi-value attribute is an attribute that can have many values for the single entity occurrence. The simple example is your telephone number. Okay, you can see. As example, let's take person A. Person A can have more than one telephone number. So when we consider about the telephone number attribute, this is the multi-value attribute. You can have more than one value for this attribute. Okay. And another example is degree. When we consider about the person can have more than one degree. So the degree is also a multi-value attribute. Okay. Phone number and likewise, you can take a multi-value attribute, but keep in remember in ER diagram we use double circle to denote the multi-value attribute. So in this case, degree, student. So you can use double circle or a double oval shape to denote this multi-value attribute. Okay. Single value attribute can be used one oval shape to denote the multi-value attribute. Single value attribute. In multi-value attribute, you use double oval shape to denote it. Okay. Okay. This is the point number 1 and 2. This is when you are creating a database. So when you are creating database, you cannot represent the multi-value attribute by using a single column. At that time, you need to classify this as a phone number 1 and the phone number 2, and you can use 2 columns to save this information. No need to memorize these things in this lesson. Then derived attributes. We discussed about simple attributes, then the composite attribute, then the single value attribute, then the multi-value attribute. Now we are going to talk about derived attributes. So in these attributes need not to be physically stored within the database. So instead of this, it is derived by using an algorithm. Okay, as an example, you can take this one. You can see DOB, that means date of birth. In the student entity, DOB is a attribute. So we can use this DOB attribute to derive your age. Okay, you can use this DOB attribute to derive your age. So age is a derived attribute. Okay. So the person age attribute can be derived by subtracting the date of birth from the current date. So this is known as the derived attribute. So you use an algorithm to create this attribute. So such kind of attributes are known as derived attributes. So to form a derived attributes, you need to use 1 or 2 attributes in your entity. Okay. So the total cost of an order can be derived by multiplying the quantity order and the unit price. As an example, you can see this is the product. This is the quantity price. And this is the quantity. If you need to calculate the total price of, that means if you need to calculate the total cost, you can use these 2 attributes to find the total cost. We can use unit price multiplied by number of quantity to find this total cost. So this is the derived attributes from these 2 attributes. Okay, then this is the estimated average speed that can be derived by dividing the trip distances by the time spent to in the fruit. Likewise, we can derive many attributes by using the available attributes in an entity. Okay, so you can see this is derived from date of birth. So we can use dash line to represent the derived attribute in ER diagram. Okay, you can use dash line to represent the derived attributes within ER diagram. Is it clear?
Yes, ma'am.
Okay. Okay. Then relationship before that. This is the summary. This is about student. We can use NIC number, then the primary key, student ID, student name, last name, first name, and the surname, then telephone number, then sex, again DOB, and the age. Okay, so this is the summary of all these things. Okay, you can see what is the primary key of this ER diagram. Can you identify the primary key?
Student ID.
Student ID. So what is the candidate key of this diagram?
NIC.
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 So what is the multi-valued attribute?
Student.
Telephone.
Telephone number.
So what is the composite key?
Student name.
Student name. So give me an example for simple attribute.
DOB.
DOB. And the sex. So what is the derived attribute?
Age.
Age. Okay, this is the summary of ER diagram. That means up to now. This is the summary up to now. Okay. Then let's discuss about the relationship. All these are from the attributes. We already discussed about the entities and the attributes. Now we are going to discuss about the relationship. So the relationship is an association between two entities. As an example, let's take these two entities. Then the association between these two entities is known as a relationship. So when we represent a relationship in our ER diagram, you can use active verb or the passive verb to denote this relationship. So employee works for department. So this relationship should be a verb. Okay, you can use the verb to denote the relationship. You can use noun to denote the entities. So we can use diamond shape to denote the relationship. So these are some examples. Takes, teach, employs. These are the example for good relationship. So as an example, student takes a class. The professor teaches a class. The department employs a professor, and so on. Likewise, we can use any active or passive verb to denote our relationship within the ER diagram. So you can use diamond shape to denote the relationship. Okay. Okay, you can see this is the professor, this is the class. The professor teaches a class. So these are two entities. This is the relationship. You can use the diamond shape to denote the relationship. Use this kind of line to connect the entity with the relationship. So you can use a line to connect the relationship with an entity. Then you can see the relationship degree in it. In last week, we were discussed about type of relationship as a one-to-one, one-to-many, and a many-to-many. The degree indicate the number of associated. That means relationships degree indicate the number of associated entities or participants to that relationship. So now we are going to discuss about this degree. So the first one is unary relationship. In this relationship, it is existent. This relationship existent within a single entity. Okay. Unary, binary, likewise there are ternary, likewise there are so many relationships. That means this by unaries become from the entity. So when we consider about unary, it is one. So in this kind of relationship, one attributes is participate. That means number of attributes participate for this kind of relationship is equal to 1. The unary relationships exist when an association is maintained within a single entity. That is, an entity set connected itself via a relationship is a unary relationship. You can see when we consider about some causes as an example. I don't know your course system. When we consider about a course like Java, if you need to take this Java, you need to complete object-oriented analysis subject first. So this is the prerequisite. That means this is the prerequisite for this course. So when we consider about these two values are belongs to course entity. Because this is also a course, this is also a course. So this object-oriented analysis and the Java belongs to course entity. So you can see to take this Java, it is needed to complete this object-oriented concept. In that case, you need this, you can see this course entity has a relationship for this entity. That means this course has a relationship for itself, like this. Course requires a course. As an example, Java requires object-oriented analysis. Okay, this kind of relationships are known as unary relationship. At that time, one entity is participating in the relationship. We can denote it like this. This is just like a recursive. I think you have some idea about recursive. This is just like a recursive. Okay. So in this case, existence of a course prerequisite means the course requires a course. That is, course has a relationship with itself. Such kind of relationship is equal to recursive relationship. Is it clear? Or do you need me to explain it again? Is it clear, or do you want more examples to clear it?
Can you explain some different examples?
Yeah. Okay, you can see. As an example, let's take a person. So you can take any female entity or the male entity for the person. As an example, let's take Kamal. Kamal is a value for this person class. So Kamal belongs to this person entity. Then there is another person as a Nimali. Nimali also belongs to this person entity. Is it correct? When we consider these are the values for this entity, is it correct? Is it correct? Yes or no?
Yes, madam.
Yes, you can take any values like this. Ajanta. Then another example, Namali. Another example, Kasun. Kasun, likewise. Okay, you can take any values to this entity. Okay, now this Kamal going to marry this Nimali. So this Kamal also belongs to this entity and this Nimali also belongs to this entity. So you can see the relationship between these two are married to. Kamal going to, that means Kamal married to Nimali. Okay, this value is from person entity. This is also from person entity. You can see the relationship is within this person entity. That means this person entity has a relationship to itself. So you can use married to relationship like this. Sorry, married to this person. That means Kamal going to marry the Nimali. Kamal is also a person. Then the Nimali is also a person. All these two are belongs to same entity. So this entity has a relationship to itself. The relationship name is married to. Is it clear?
Yes, ma'am.
I think it was clear now. ඒ කියන්නේ අපි දැන් ගත්තම මොකක් හරි අපි person කියන class එකට 1 plus set of values ගොඩක් තියෙනවානේ කමල් නිමල් අම්මල් සුනිල් ඕන කෙනෙක්ව ගන්න පුළුවන්. හැබැයි අපි කමල් කියන කෙනා නිමල් කියන කෙනා මැරි කරා කියන්නේ ඒ දෙන්නම අයිති වෙන්නේ same entity එකට. ඒ කියන්නේ person කියන entity එකට. ඒකට අපි කරන්නේ person කෙනෙක්ව තමයි තව person කෙනෙක්. මොකද person කෙනෙක් animal කෙනෙක්ව මැරි කරන්නේ නැහනේ. person කෙනෙක් මැරි කරන්නේ තව කවුරුහරි person කෙනෙක්. So person has a relationship to a person. Okay. That means person going to marry a person. So you can say same entity. The relationship exists within the same entity. Such kind of relationships are known as unary relationship. Is it?
Madam, excuse
Oh, go ahead with that.
me. දැන් ඉස්සල්ලා first example එකයි මේකේ අතර difference එකක් වඩ දැනෙනවා. දැන් අර ඒකේ ඉස්සල්ලාගේ free request එකක් විදිහට object oriented තියෙනවා කියලානේ. එතකොට ඒ දෙකේ මේකේ difference එකක් තියෙනවා. දැන් මේක නම් level එක equal, it's true. But the previous one you said that the Java is one that object oriented is free request.
Yeah, but when we consider about Java and the object oriented, all these two are below.
Object oriented, yes.
Object oriented කියලා subject. So this is object oriented. Then the next one is which one? Java. So when we consider about these two are belongs to same entity. When we consider about object oriented, it is a course. When we consider about Java, it is also a course. Okay. So this Java needs to pre-request this one. So that means Java requires object oriented. So the same entity, within same entity, you can see a relationship like this. Okay, wait. Let's take Java. Before that, like this. Oh, sorry. You can take an entity like this. Course. Okay. So give me some example for this. That means give me some domain. What are the domains? So what can be taken as a domain for this course? Give me some example for courses. In your syllabus, what are the courses that you are following?
Computer science,
Computer science. Okay. Then
maths, chemistry, physics.
not that not like this. Let's take like this as a computer science subject. Let's take not the course. Let's take subject. I think it was clear. Let's take a subject. So when we consider about subject, you can see in our department we offer the course. Sorry. Subject. Okay, so this is the entity. So in our department, we offer Java. Then object-oriented analysis. You are from first level now. in your second, third level, you can see DBMS, this one. That means database designing and implementation. Then there is another course in level 5, or I don't know in which level, ADBMS. Another subject, okay, advanced database management system. This is database designing and implementation. So you can see, no, I'm not going to use any Google form to mark your attendance, but I'm taking your attendance by using the Zoom report, okay. You can see these are the subjects. So as an example, let's take this one, Shanal. When we consider about Shanal is a student in our class. So he is going to follow this DBMS in level 3. Now, as an example, let's take now he is in level 3. After 1 year, he is going to level 4. In level 4, he is like to take this. That means he is need to take this ADBMS. Okay, all these are belongs to subject entity. So to take this one, it is needed to complete this database designing and implementation. So to take this one, it is needed to that means it is requires this one to complete. Okay, so you can see ADBMS කරන්න අපිට DBMS කියන subject එක කරලා තියෙන්න ඕනේ. හැබැයි ADMS උයි DBMS උයි දෙකම අයිති වෙන්නේ. මේ කියන්නේ advanced database management level 4 එකේදී Shanal advanced database management system කරන්න යනවා. හැබැයි එතකොට එයාගේ බලනවා එයා first level එකේදී DBMS complete කරලා තියෙනවද කියලා. හරි. එයා complete කරලා තියෙනවා. එහෙනම් එයාගේ අවශ්‍යතාවය තමයි එයාට ADBMS ගන්න require කරනවා මෙන්න මේ DBMS කියන course එක. හැබැයි මේ දෙන්නම belongs වෙන්නේ subject කියන entity එකට. එතකොට ඔයාලට පේනවද මෙන්න මේ subject කියන එක නම් මෙයා subject එක මෙයා subject. તો relationship එක තියෙන මේ subject කියන entity එක ඇතුලේ නේද?
ඔව්.
අන්න ඒක නිසා තමයි මෙතන requires. So this ADBMS requires DBMS. Okay. Take a subject කියලා ගන්න පුළුවන් course කියලා ගන්න පුළුවන්, that's up to you. Course requires another course. Okay, so in our example, ADBMS requires DBMS as a prerequisite. Okay, is it clear now?
Yes, madam, that's okay now.
Then let's move into so this is so called as a recursive relationship. You can see this entity has a relationship to itself, that means recursive. So this is a recursive relationship. I think you have some idea about this iterative and the recursive relationships and the iterative and the recursive modeling. Then let's move into binary relationship. So when we consider about binary means two. You can see in this relationship there are two entities needed to be exist. Okay, in binary relationships exist when two entities are associated. You can see professor teachers class, there are two entities. By using the teachers relationship, such kind of relationships are known as binary relationship, two entities. If one entity is participate to create a relationship, such kind of relationships are known as unal relationship. When we consider about that means two entities are participate for creating a relationship, such kind of things are known as a binary relationship. Then there is another relationship like ternary relationship. You can see there are three attributes get together to form a relationship. You can see this is the contributor, or this contributor can be a people or any institute. So this contributor going to donate money for research. That means when we consider about research work has a fund. Okay, so these people or this institute going to funded for this fund. Okay, after that, this recipient means researchers. Okay, contributors means people or an institute, fund mean any donation, recipient mean researchers. So the researchers receive this fund through the fund content. Okay, people's going to donate for the fund, and researchers use this fund for their research work. Okay, so at this time you can see there are three entities get together to form a relationship. So this kind of relationships are known as ternary relationship. Okay, in this case, you can see this is a multi-value attribute. Definitely this is a multi, that means M2M relationship. That means many-to-many relationship. One contributor can donate it for many fund, and one researcher can receive donation from many funds. So this is a many-to-many relationship. In this kind of relationship, we use first letter of these three entities to denote the relationship. In the contributor, C is the first letter, fund, F is the first letter. In the recipient, C is the first letter, C, F, R can be used to denote the relationship. Okay, I'm going to discuss this with the database. Okay, otherwise, I think it is difficult to understand. So you can see again, there is a question like explain it again. So you can see there are three attributes participate to form a relationship, like contributors, then the fund and the recipient. So the contributors donate money for the fund, and the recipient, that means the researchers. Researchers are belongs to this recipient category. So the researchers use this fund for their research work. So you can see three categories for the same scenario. So same, that means one relationship, within one relationship, you can see three attributes, sorry, three entities. Okay, I'm going to, then you can use first letter of each entity to denote the relationship. In the ternary relationship, you can use the first letter of the entities to denote the relationship. Okay, you can see these are the tables. So the contributors and the recipient and the CRF and the fund, you can use, you can see this Pathum denoted his, that means his money for fund F1 and the F2. The amount is equal to this amount. Okay, then the researcher R1, not R1, R2 and R3, and the R2 use this F1 fund. So this F1 fund is denoted by C1 and the C2. That means this is funded by Pathum and the Duli. So this fund amount is equal to 60,000. So this 60,000 is denoted by Pathum and the Duli. This is available under the F1 category. This F1 fund is going to used by R2 researcher and the R3 researcher for their research work. You can see this is the relationship CFR. So you can see in this case, fund ID, then the contributor, then the researcher and the contribute attribute. So this is the database for this ER diagram. So in this case, this as example, let's take Amal. Amal going to denote 50,000 for the fund one. This fund one is for cancer researchers. That means cancer research work. This fund one is for the cancer research. One researcher like Kamal is the researcher in this category. So this Kamal received this fund through this fund F1 ID. Okay. This is known as a ternary relationship. ඒ කියන්නේ relationship එකට entity තුනක් calculate වෙලා, يعني entity තුනක් සහභාගී වෙලා තියෙනවා. මේකෙදි කරන්නේ දැන් අපි හිතමු අමල් කියලා කෙනෙක් මොකක් හරි fund එකක් කියන්නේ denote එක fund එකක් දෙනවා. මේක cancer work වලට ගන්න කියලා. ඒතකොට ඒ fund එක ගන්නවා කමල් කියලා කෙනෙක්. So ඔයාලට පේනවා දෙන කෙනයි ගන්න කෙනයි මේ අදාළ fund එකයි. හරිද? ඒතකොට ඔයාලට පේනවා මේ රිලේෂන්ෂිප් එකට තුනක් තියෙනවා. අපි මේ data තියාගන්නවා නම් කවුද මේක දුන්නේ? කොයි ෆන්ඩ් එකටද කවුද මේ ෆන්ඩ් එක යූස් කරේ. ඔයාලට පේනවා තුනක් තියෙනවා කැටගරිස්. So ඒ තුනට අදාළ data අපි තියාගන්න ඕනේ. ඒතර අපි database එකේ මේ තුනටම අදාළ data තියාගන්න ඕනේ. So එතකොට අපිට පේනවා තුනක් entities සහභාගී වෙලා තියෙන එක relationship එකට. So this kind of relationship is known as a ternary relationship. You can use the first letter of each entities to denote the ternary relationship. Okay? Is it clear? This is the exam. This is the detail of this database. You can go to it. Is it clear?
Yes.
Yes.
Okay. Then let's move into the cardinality. Okay, when we consider about a cardinality, before that there are three types of relationship: unary relationship, binary relationships, and the ternary relationship. Most probably you can see the unary and the binary relationships in the ER diagram. It is very rarely use this ternary relationship in the database, that means ER diagram and the database. So these three types of relationships are available in under the relationship category. Unary relationship, one entity is participate to create a relationship. In binary case, two entities are participate to create a relationship. In the ternary case, three entities are participate to create a relationship. Okay, then let's discuss about cardinality. So when we consider about cardinality, it's express the specific number of entity occurrence associated with one occurrence of a related entity. In last week, we were discussed about one-to-one relationship and one-to-many relationship and many-to-many relationship. I think you have some idea about this type of relationship. At that time, you can see there are two values as a one-to-one, one-to-many, then the many-to-many. So by using that type, same name, recursive relationship is known as a unary. Okay, unary relationships are known as recursive relationship. Okay. So you can see. So this is about cardinality. When we consider about a cardinality, the specific number of entity occurrence associated with the one occurrence of the related entity. As an example, let's take this is A and B. In this cardinality means how many number of occurrence associated with this entity. It's a okay. This cardinality express how many number of occurrence available from this side with this entity. Again, you can take a cardinality of this side, how many number of occurrence associated from this side with this entity. Likewise, you can define the cardinality. So the XYZ University administrator limit the professor to teach in a maximum of 3 classes per semester. As an example, this XYZ University administrator decided to limit the number of classes per semester for a professor. So the maximum number is equal to 3. Okay. Therefore, the cardinality rule governing the professor class associated expressed as one professor teaches up to 3 classes per semester. So one professor can conduct maximum 3 classes per semester. A professor may be assigned to teach 1, 2, or 3 classes. So the class must have only one professor. So when we consider about one professor can be teach for 1 class or 2 class or 3 class or a 0 classes. Okay. So this is the relationship. You can see professor teaches class. So according to the XYZ administrator, the maximum number of classes that conducted by a professor is equal to 3. So when we consider about this one, this side is for this professor. Okay, professor. So what is the maximum number of classes? It is 3, the minimum number of 0. So we can express the cardinality like this. So this is for the professor. So when we consider about a class, you can see the class can have only one professor. Class from maximum gana 1, minimum gana 1. If it is a class, it is needed at least one professor to conduct this class. Okay, so when we consider about class, cardinality of class, minimum number is equal to 1 and the maximum number is also equal to 1. So you can express the cardinality in this side like this according to the class entity. Okay. Again, that means XYZ administrator that means they decided to limit the student maximum number of 6 classes per semester. So student can only take 6 classes per semester and class size may be limited to 35 students. Okay. You can see this relationship is student enrolls, sorry, this is enrolls. This should be in capital letters. Okay. It's difficult to write capital letters for me. That's why I write it like this. So this is the class. According to their administrators, they are going to decide the limit the number of students per class. So when we consider about the class, it should have a class size with 0 up to 35. The maximum number of students for the class is equal to 35. So when we consider about a student can only take maximum number of classes. That means the number of classes that the student can be taken is equal to, that means maximum number is equal to 6 class. So you can denote these two with this ER diagram or this ER diagram. So I'm going to do it like this. Okay, let's take the student cardinality. So one student can take many class. The relationship is equal to 1 to many. You know, one student can take many class. So the relationship is equal to 1 to many. So when we consider about cardinality of the student, so what is the maximum number of classes that can be taken by this student? So what is the maximum number?
6.
6. What is the minimum number?
1.
1. So this is the cardinality of this student. You can express this like this. Then when we consider about the class, so what is the minimum number of students in a class? To form a class, what is the minimum number? Class එකක් තියන්න නම් කොච්චර තියෙනවද minimum number එක?
1.
1.
What is the maximum number?
35.
35.
35. So this is the cardinality of the class. Is it clear now? Is it clear? So this is the end of relationship 1 to 6. So this is the 0. No, it is not a case. You can take 0 or a 35. So I think it is suitable to take this as a 1 because to exist a class, it is needed at least one student. Okay. So in this case, I think the student enroll 1. Yeah. So
Ma'am, in which cases does 0 come? In the first example, in the professor, the cardinality is 0 by 3 now.
yeah,
Can we?
there are requirements. So if the university requires So as an example, you are going to create a database for OUSL. So it is depend on your requirement. That means OUSL requirement. So if they need to take, that means if you need to take the like this, so but it is possible to class to have no currently enrolled student. So there are some courses no students are enrolled for this course. Such kind of case you can use 0 as a minimum number. That's depend on the requirement. Okay. ඔයාලා දැන් database එකක් create කරන්න කලින් requirement analyze කරන්න ඕනේ. අපි requirement ගන්න ඕනේ කොහෙන් හරි. හිතන්න මගේ company එකට ඔයාලා database එකක් කරන්න යනවනේ. So you need to gather the requirement from me. So the number of candidates depends on my requirement. Okay. In your exam, it is available in your question. Okay. දැන් හිතන්න දැන් ඔයාලා ඇත්තට හිතන්න එක්සෑම් එක මම CAT එක්සෑම් එකට මේ වගේ එක්සැම්පල් එකක් දෙනවා මොකක් හරි සිනාරියෝ එකක් දෙනවා ඔයාලට කාඩිනේටි එක්ස්ප්‍රෙස් කරන්න. එතකොට මම දෙන්න ඕනේ මොකක්ද මැක්සිමම් නම්බර් of කාඩිනේටි එක මොකක්ද මිනිමම් නම්බර් of කාඩිනේටි එක කියලා. Okay. Is it clear? So it's up to the requirement. Okay, let's take another one. This one. Yeah, this is the database. So you can go to this database. This is available in your book also. So this one. When we consider about this student, so like this. The cardinal limits 1 for the class entity indicate the minimum number of professors required to teach the class is 1 and the maximum number of professors is 1. Okay. Like this, always it is given that the cardinality to express them in a ER diagram. So no need to express this cardinality in ER diagram. It's only repeat this one. What is the relationship? Okay. Let's take like this. Employee works for department. Okay, for department. In this case, one employee can work for many classes. Okay. Yeah. So when we consider about this scenario, when we consider about the employee, the minimum number of employee in the department is equal to 1 and the maximum number of employees is equal to 5. Okay, so this is the cardinality. You can denote this cardinality by using, this is a department employee, this side. So like this, you can express the cardinality according to my requirement. Okay, so that's up to me to define the cardinality. So you can express this like this. Okay. Okay, before that, do you have any questions before moving to next lesson? Can you, if you have any question now, you can raise your question. A class may enroll 0 to 35, but it is possible for have to no class currently enroll student during the first few days of the student registration period. That's why we can take it as a 0. How many units up to ER diagram? In next week, I think with the time we can start ER diagram in next week. So up to ER diagram, we are going to test a CAT exam. So in CAT exam, sometime you can have a question about real world scenario. So you have to map it into a ER diagram. So to map this mapping to ER diagram, you need to have some idea about this cardinality, then the relationship type, then the entities, and how we can denote these things. Likewise, what are the attributes? So likewise, you can have some idea. Is there? Yeah, wait. Okay. Do you have any other question, madam? Are you going to put the recordings of this session to the e-learn, not receive the course material, ma'am? You can contact CRC for your about your, that is for your course material. So you can contact CRC and confirm whether how you can take this course material and recording. I'm going to send your, that means link of the recording to the WhatsApp group, and okay, I can upload it into a e-learn. E-learn means learn or USL. Okay, there are two. So yeah, exam is face to face. No. It's, I don't know. Sometimes it can be a face to face, or sometimes it can be a online exam. That's depend on the current situation on the of the country. Okay, I think all questions are clear now. Okay, do you have any other questions? එහෙම ඔයාලට මොකක් හරි තේරෙන්නේ නැති තැනක් තියෙනවා නම් අහන්න. මොකද දැන් මේ බේසික් එක නැතුව මට ER diagram එකක් හදින හැටි කියලා දෙන්න බෑ. ඒකට ආයෙත් අහනවා මිස් මොකක්ද composite key එකක් කියන්නේ මොකක්ද derived එකක් කියන්නේ. ඒ නිසා මේ ටික ඔයාලට ඕනේ ER diagram එකක් අඳින්න. and ER diagram එකක් කොහොමද map කරන්නේ database එකකට කියන concept එකට යද්දි. so ඔයාලට මම ප්‍රශ්නයක් තියෙනවා නම් දැන් අහන්න පුළුවන්. It's up to, I think that it's 1 to 12. Lesson number 1 to lesson number 12. That means up to developing an ER diagram. Okay. Okay. Then let's move into our next one. It is also about entity relationship. That means the second part of this lesson. Let's discuss about weak entity. Again, we are going to discuss about the entities. So this is about weak entity. A weak entity is an entity relationship diagram should satisfy the two conditions. So when we consider about a weak entity, in a weak entity in an ER diagram should satisfy two conditions. The first one is it is existent dependent. That means that entity cannot exist without the entity with which it is has a relationship. As an example, you can see like this. If this is a weak entity, it is needed to have this one. So this cannot exist without this entity. So this is known as existence dependency. And also when we consider about this weak entity, it has a primary key that is partially or totally derived from the parent entity in the relationship. So there are two conditions for the weak entity in ER diagram. The first one is it is needed to have an existent dependence. Then the second one is it has a primary key which is partially or totally derived from the parent key. As an example, let's take this one. So this is A, this is B. So this is the weak entity. So this weak entity has a primary key which is derived from this parent key. Okay, so and also it is needed to have this key or this entity to exist this relationship or exists this weak entity. Okay, first let's discuss about what is this existence dependency. If an entity's existence depends on the existence of one or more other entities, it is said to be existence dependent. Okay, as an example, ma'am, can you directly upload the recording to the learner user request rather than a Google Drive? Because we don't have to chat. It is unable to upload that size of video directly to your learner user. It has a limited size. Most probably our recording is more than that size. That's why we provide you a Google Drive link. Okay, I'm going to explain the weak entity. So if a weak entity in an entity relationship should satisfy two conditions. The first one is existence depends. That means this weak entity cannot exist without the entity with which it has a relationship. That means, as example, let's take this is a weak entity. This cannot exist without this one. So this is known as a existence dependency in simple form, and this need to have this has a primary key which is derived from this one. So partially or totally derived from this strong entity. So if this is a weak entity, definitely this is the strong entity. No, so this has a relation that this entity has a primary key which is derived from this one. Let's discuss these two in detail. So when we consider about the existence dependence, in the entity's existence depend on the existence of one or more other entity, it is said to be existence dependence. As an example, you can see this course and the class relationship. Okay, so this is one-to-many relationship. You can see course and the class relationship. This is one-to-many relationship. You can see the class table has an attribute CRS code. Okay, which refers to the course table. It is clear that course entity does not exist without having this non-existent table. As an example, let's take this course has class. Like this. So you can see this course has a primary key. I'm going to draw it in this place. This is the class, this is the course. When we consider about course, this is consist with the course ID. This is the primary key, then the course name and the number of credit. Okay, so this one is class code, then the course code and the date and the room number. Okay, likewise you can see the attributes for these two entities. Then you can see this class cannot exist without a course. So you can see the classes are available under the course category. That means if you have a class, this is definitely this belongs to one of the course. So this class cannot exist without a class. Okay, so this is a weak entity. When we consider about a class, it's a weak entity. At that time, we can use class code and the course code as the primary key of this weak entity. Then as an example, let's take a class and a course. So this class, as an example, this is the class. So this is on 20th October. So this class belongs to database designing and implementation course. Okay, so this class cannot exist without that course. මෙහෙම class එකක් තියෙන්න පුළුවන් ද course එකක් නැතුව නිකන් ඔහේ? No, this class belongs to database designing and the implementation details. So this sorry, implementation, database design and implementation. So this class is belongs to this course, that means database and database designing and the implementation. So the class is weak entity. So this class is a weak entity. This is depend on course. So at that time we can use, so this is definitely weak entity. So it is needed to have course in a relationship to exist this one. And you can see this class, that is course code, used to form the primary key of this class. This and this, the combination of these two attributes. So the second point is also clear now. It is needed to have a partially or totally derived key from the parent key to exist the relationship. So this class is belongs to this course, so it is needed course ID and the class ID to be as a primary key of this class. Okay. This is the class is existent depend on the course. The course table must create before the class table create. This is in a database, so it is needed to create a class table before, sorry, course table before creating the class table, because this is from this table. So if you need to create, if you need to insert the values for this value should be available in this course table. So it is needed to create this one first, this one second. Okay. As example, let's take our class. So when we consider about this class, this is the third session. That means third class of your database designing and implementation modules. So if this third, if it is needed to exist, this third class is definitely have a course like database designing and the implementation. So this class is totally depend on that. That means depend on course entity. So class can be taken as a weak entity. So when we consider about this class, we can use the primary key of the course entity and one of the attribute from the class entity to create a composite primary key. The second requirement, the first one is already discussed in this slide. You can go through the slide. So the table designer usually determine whether an entity can be described as a weak, and the examination of the relationship between course and the class may cause you to conclude that class is a weak entity to the course. Okay. After all, if you examine class row, it is clear that class cannot exist without a course. You can see this cannot exist without this value. So it is needed to have this course attribute. Then, yeah. After all, if you examine the class row, it is clear that class cannot exist without a course. So there is a existence dependency. So this is known as a existence dependency. That means class cannot exist without the course. Okay. Then the second scenario is it is stated, this is the second requirement. When we consider about second requirement, it has a primary key which is derived from the parent key, or partially or totally derived from the parent key. So you can see when we consider about the class, this is the primary key. That means this is a composite key with two attributes. The first one is course code from the course table and or a course entity, and the class selection from the class entity. So this is this primary key is partially derived from the course. Keys there are two keys as a primary key. So you can see this is a partially derived. This is partially derived. If it does not have this one, this is totally derived from the class that is course entity. So this is the partially derived from the course entity. So the class is a weak entity by the definition. So existence of weak entity is indicated by using a double rectangle. So if you need to insert a weak entity to your ER diagram, you can use double line to denote the weak entity. So that means this weak entity is dependent on this one, and it is needed to have partially or fully derived primary key from the parent entity. So example, this one. Okay, according to example, I'm going to discuss this example. Okay. As an example, let's take this is XYZ. Wait, yeah, company. As an example, a company going to introduce a insurance policy. A company going to introduce a insurance policy for the employees and his or her dependents in a company. That means one company is going to introduce an insurance policy for their employees and their dependents. For the purpose of describing the insurance policy, employee may or may not have a dependent. So you can see, let's take this one as B company. In this B company, they're going to introduce a insurance policy. Okay, insurance policy for their employees and his or her dependent. Okay, this company going to introduce a insurance policy for the employee and his or her dependent. Okay. Then you can see when we consider about the employee. So this employee policy is available for employees in the company. No? So if as an example, let's take this X is going to take this insurance. So it is needed to have this. That means it is needed to become an employee. This X to be employed in this company. දැන් X කියන එක්කෙනා ගන්න යනවා insurance එක. එහෙමනම් එයා B company එකේ employee කෙනෙක් වෙන්න ඕනේ. So it is needed to have an employee in this B company to take this insurance. So yeah. But the employee may or may not have a dependent. So this insurance policy is for employee and their dependent. So when we consider about the employee, he or she can have a dependent or cannot have a dependent. That's depend on the employee. That means employee may or may not have a dependent, but dependent must be associated with employee. But dependent must be associated with this employee. Without having any relationship with this employee, we cannot. That means this dependent does not have. That means this one does not allows to have this insurance policy. That means you cannot get the insurance coverage at this company as a dependent unless you happen to be a dependent of the employee working for the XYZ company. ඒ කියන්නේ XYZ කියන company එකෙන් අපිට මේකක් මොකද්ද මේ policy එකක් insurance policy එකක් introduce කරනවා. ඒ insurance policy එක ගන්න නම් එක්ක ඔයා වැඩ කරන්න ඕනේ company එකේ. එහෙම නැත්නම් ඔයා ඒ company එකේ වැඩ කරන කෙනෙක්ගේ dependent කෙනෙක් වෙන්න ඕනේ. Okay. So XYZ company now you can see this dependent is totally depend on this employee. That means this dependent cannot exist without this employee. So the dependent is a weak entity. You can see this dependent is a weak entity. We can denote this weak entity by using a double rectangle. And you can use this circle to denote the, you can use this circle to denote the weak entity. So this side is the weak entity. You can see, weak entity inherit all or part of the primary key from its strong entity. For example, let's take the dependent entity's key will be inherited from the employee entity, employee number, last name. These are the fields available. That means attributes available in the employee. These are the attributes available in the dependent. If this is a weak entity, so this is depend on this employee. So it is needed to have a primary key of the employee for the primary key in the dependent entity. So we can include this primary key and the another key as a composite key for this dependent attribute. So you can use this one and this circle to represent the weak entity. Okay. Is it clear? Is it clear? Then Nathan, do you need to explain it again? Is it clear?
Yes, ma'am.
Yes, madam.
So before that, in the weak entity, this circle is not belong to weak entity. I am explaining it in upcoming lectures. So this rectangle shape is, double rectangle shape is used to denote the weak entity. This means optional or a mandatory. Okay, I think yeah, participant relationship, optional or a mandatory. This circle is belong to that. Only double rectangle is used to denote the weak entity. Then let's discuss about the relationship participants. That means participation. There are two types of relationship, optional and the mandatory. When we consider about the optional participants, that means participation, if one entity occurrence does not allow requires a corresponding entity occurrence in a particular relationship, then the participation is optional. As an example, let's take a professor and the teachers. Professor teaches, that means professor teach the class. Example, in this case, professor may teach no classes at all. So, or you professor may teach many classes. That means maximum 3 classes. On other hand, if a class is or taught only by one professor. So that is possible for a professor not to be teach a class. So this is optional. When we consider about the professor teacher's class example, you can see when we consider about the relationship between the professor and the class. So professor does not need to have any class. So it is okay to have no class. So this class is not mandatory for this professor. So this is a optional. So you can denote this optional by using this circle. So in this case, this is should be in optional entity side. Okay. So this professor does not, when we consider about the professor, class is not a mandatory. So this is a optional. The class is optional. So you can use this circle to denote the optional relationship. This circle is denoted in optional entity side. Okay. Is it clear? Is it clear?
Yes, madam.
Okay. Then about mandatory case. In mandatory case,
Yes, madam.
if one entity occurrence must require at least one corresponding entity occurrence in a particular relationship, such kind of participations are known as mandatory participation. As an example, again, professor teaches the class, and in this case, professor needed to have at least one class. That means professor must teach at least one class, and the maximum number is equal to 3. So this is the requirement. So the requirement is professor must teach at least one class, and the maximum number of class equal to 3. So it is needed to have this class, at least one class for this professor. So this class, now this class is depend, that means professor is depend on this class. So this is a mandatory relationship. So this relationship is a mandatory relationship. That means mandatory participation not needed to show specially. This is a mandatory. Okay, is it clear? In optional case, yeah, this is the optional case. In this optional case, it is not, if one entity occurrence does not always requires a corresponding entity occurrence in a particular relationship. But when we consider about a mandatory case, if one entity occurrence must require at least one corresponding entity occurrence in a particular relationship. Some kind of relationships are known as mandatory relationship. But we do not specially highlight this mandatory relationship. All these are belongs to mandatory case. If it is an optional case, we highlight the optional case by using a small circle. Okay, I think it was clear. Now the recursive entity, we discuss about this one in under the unary relationship. In the recursive entity is, you can see, relationship can exist between occurrence of the same entity. So in a unary relationship, the relationship occur within the same entities. This entity is known as a recursive entity. We already discussed about the unary relationship. This is a unary relationship. That means employee managed employees. So in this case, same entity has a relationship with the same entity. So this entity is known as a recursive entity. Okay, is it clear? This entity is a recursive entity. Can you identify this scenario, employee manage employee? Is it clear? Can you identify employee manage employee? What is this employee manage employee?
Higher employee manages the
Yeah.
lower level.
Employee managers manage the lower level employees. All these employees are belongs to higher level and the lower level. Both employees are belongs to employee entity. That is depicted. That is represent. That case is represent from this diagram. Okay. Yeah. Let's take the interval at 10:30. Before that, you can see this one. This is the employee code, employee name, and the employee manager. You can see when we consider about this Mendes, employee code is 101. This employee Mendes is managed by this one, the Silva. Mendes, the Silva is the manager of the Mendes. And also the Silva is the manager of Yapa, Costa, Pereira, and the Fernando. But all these are belongs to employee category for an employee entity. So this is known as the recursive entity. So this is the recursive entity. This relationship is a unary relationship. Okay, this is about employee is married to employee again. That means a person is married to a person. You can see same entity, relationship is within the same entity. This is, what is this entity? What is, you can define a name for this entity. What is the name? What is this entity? Employee. So we can say recursive entity as this entity. Okay. No need to put your student numbers and the names into the group. Again, this one. So you can see employee numbers, employee first name, and the employee name, first name and their post. So you can see when we consider about this Sarath Bandara is married to Nimala Bandara, but all these both of them are belongs to employee entity. Okay. So in this case, you can see one employee can marry one employee. This is one employee can manage many employee. You can see one employee can manage many employee. In this case, one is married to one. That means one-to-one relationship. Then there is another one. M request M. That means a course may be a request to many courses, and each course may have many other courses pre-request. As an example, if you need to take Java, you need many courses as pre-requesting. When we consider about this relationship, this is many to many relationship. Okay, you can see this is a table for this. You can go through this table as an example. I'm going to take this one. Course code. Okay, to take this one, it is needed to complete max 243. Likewise, you can see this is the relationship between these two tables. Then about attributes in relationship. Before discussing this, let's take a small break. Now it's 10:32. Let's meet again at 10:45. I think it is enough to have a 15-minute break. So you can take a 15 minutes break. Let's meet again at 10:45. Shall we start now? Shall we start now?
Yes, madam.
Okay. So let's discuss about the attributes in a relationship. We already discussed about attributes in the entities. Okay, we discussed about the attributes in the entities. Now we are going to discuss about the attributes in a relationship. Okay, can there be attributes which are needed only when the relationship happens? So this kind of attributes occur when the relationship is happen. That means when the relationship happen. Okay. So example, you can take the customer and the order. You can see customer can place an order. We need to track the date of an order by the customer. So if you need to track the date, so you can see there are two entities as the customer and the order. If you need to track the date, this order should be placed. So this date is occurred when this order is placing. Okay, so in this case, we can take this order date as the attribute in the relationship. You can see this order date occur when customer place an order. So this is occur when order in processing. So in that case, this is can be taken this under can be taken this date of order under the relationship. Order date cannot be put on customer or order. We need it when the customer place an order. Okay, so this order occur when the customer place an order. Therefore, this attributes is belongs to this place relationship. You can denote it like this. No need to take another color for represent this one. You can represent place under the relationship. Okay. So you can see when you are dealing with the attributes, there can be the attributes that the value get when the relationship happens. Such kind of relationships are known as relationships in the attributes in that such kind of attributes are known as attributes in a relationship. So think your friend borrowed a book from you. You need to store the borrowed date, but this borrowed date occurred when your friend borrows a book from you. So you can see this borrow date occur when your friend let's take the student borrows a book from a library. So this one occurs when this relationship happened. So this borrowing date belongs to this relationship. Such kind of attributes are known as attributes in the relationship. Okay, so now you can see we can denote these attributes in the entity as well as the relationship. Okay. Then about composite entities. Is it clear? This one, attributes in the relationship, is it clear? These attributes occur when the relationship occurs. Is it clear?
Yes, madam.
Okay. Then let's discuss about the composite entities. When we consider about the composite entities, the relation model, when we consider about this ER diagram, they are like to, or they require, that means relational model. Under the relational model, they require to use 1 to M relationship in a ER diagram. Okay. In ER diagram, we mostly use this 1-to-1 and 1-to-many relationships. So if the relationships are encountered as M-to-N relationship, we can create a bridge between these two entities to display such relationship. You can see there are so many relationships belongs to M-to-M. So if you need to depict this M-to-N relationship within a ER diagram, so it is needed to convert this one into 1-to-1, 1-to-M relationship. Okay, to convert this M2, that means many-to-many relationship into one-to-many relationship, you can create a bridge entity that compose the primary key of each entities to be connected. So this bridge entity is known as composite entity. Okay. You can see that means attributes in a relationship occur when the relationship, as an example, you are going to place an order. So customer place an order. So this date of, that means order date is occurred when this relationship happened. ඒ කියන්නේ මේ relationship එක වෙනකොට තමයි මෙන්න මේ order date එක create වෙන්නේ. The customer and the order, there are two entities as the customer and the order. So this customer going to place an order. So this order date occur when customer place a order. So this is happening, that means this is creating when happening this relationship. So such kind of attributes are known as attributes in a relationship. That means attribute in relationships. Okay. Again, about the composite entity. So in the ER diagram, we can only denote this one-to-m, that means one-to-many relationships. So you can see there are so many M-to-N, that means many-to-many relationship in the world. So if you need to plot this M-to-N relationship in the ER diagram, we need to convert this many-to-many, that means M-to-N relationship into one-to-many relationship. To convert this one, it is needed to have a bridge entity. So this bridge entity is consist with the primary key of one entity and the primary key of both entities. So this bridge entity is known as the composite entity. So the composite entity can be represented by using a diamond shape within a rectangle. So you can see a student enrolls in course. This is many-to-many relationship. So to represent this one, it is needed to make this one into a one-to-many relationship. To convert this into one-to-many relationship, it is needed to create a bridge entity. So this bridge entity is known as a composite entity. You can take this enrollment in. So this is a verb. Now we are going to convert it into a noun. So you can convert as enrollment. You can represent this one as a rectangle, sorry, as a diamond shape within a rectangle. So at one time, this is as a verb, that means as a relationship. Another time, this is a entity. So these kind of entities are known as composite entities. Okay, you can see one student can take many courses. When we consider about one course, it can take many students. So this is many-to-many relationship. So when we consider about this many-to-many relationship, it is difficult to plot this in a ER diagram. So you convert it into a composite entity like this. In this case, one student enrolled for many courses. So when we consider about one enrollment, it is belongs to one student. So this is one-to-many. When we consider about enrollments, one course can have many enrollment. When we consider about one enrollment, it is belongs to one course. So this is one-to-one relationship. So this many-to-many is divided into one-to-many and many-to-one like this. Okay, so this is known as a composite entity. So the composite enrolled entity is existent depend on these two entities. You can see composite entity is composed with the primary keys of the entities that are connected by a composite entity. So this is consist with the primary key of this one and this one. You can see this is the three table. This is the student table and this is the class table. This is the enrollment table So this is also entity, this is also entity, this is a composite entity. This can be act as a relationship and the entity. So in this case, you can see this is the primary key. This is the primary key of this one. You can use these two primary keys. Wait. So this is not a student class. So this is the student class. This is the class. This is the enrollment class. You can see this is the primary key of this table. This is the primary key of this table. This enrollment composite entities having both primary keys from both two tables to create this table. Okay. Is it clear? Then a class may exist even though it contains a number of no student at all. Therefore, the optional relationship is one. Okay, so this is the whole thing. Yeah. This is the whole thing about this composite relationship. So when we consider about the enrollment and the student and the enrollments in the class, that means this relationship, student enrolls in class, this one. Students enrollment in course. This is course. In this case, it's a class. So let's take it as a class. You can see students enroll in class relationship. So in this case, this is many to many. Before converting into one to many, this is many to many. In this case, you can see a class may exist even though it contains no student. So class can be contain no students. So when we consider about class entity, so this is optional. It can have students or cannot have a student. So this is optional. So you can denote this optional by using this circle. Okay. Is it clear? Up to now, is it clear? What is this composite attribute and how we can denote this end-to-end relationship by using a composite attribute? So is it clear?
Yes, ma'am.
Yes, madam.
Okay, finally you can create a ER diagram like this: student and the enroll or enrollment, then the class. So these are the attributes in this entity: student name and the student number. This is the primary key. So then we consider about class. Class code is the primary key. These are the other attributes. By using these two contributes, entities, it creates a composite entity like enroll or enrollment. You can see one to many and many to one relationship between these two entities. So when we consider about this enrollment, this is not mandatory. That means student is not a mandatory case for the class. So it's a optional. That's why it's not like this. So when we consider about composite key, it is consist with class codes. Again, same thing, repetition. Student number from this class. This is the primary key of the student class. That means student entity. Class code is the primary key of this class entity. You can see these two are connected to create a primary key of this composite attribute, and there is another attribute as a enroll grade. Is it clear? Is it clear? Or do you have any questions up to now before moving to next part? Can you
explain it again?
Okay, I can explain it again. So in ER diagram, it is difficult to denote this end-to-end relationship. At that time, we need to convert this end-to-end relationship. Not end-to-end means many to many. Okay, many to many relationship into one to many relationship. So to convert this one, we are going to create the bridge entity. That means you can see this one. Wait, this one. So this is one to many. So we are creating a bridge entity between these two entities. Okay, bridge entity can be created like this enrollment. So in this case, this M to N can be created. This M to N can be divided like one to many and many to one. Okay, to create this relationship, it is needed to depict this relationship by using a composite key entity. So you can see composite entity is enrollment. When we consider about that, now student can enroll in many courses. When we consider about one course have many students. So this is many to many. Then this is the enrollment. When we consider about the relationship between the enrollment and one student can enroll in many courses. So when we consider about one course have many enrollments. So likewise we can reduce this M to N relationship into one to many relationship. So it is needed to include the primary key of this entity and the primary key of this entity for this composite entity. And also if you have any other attributes, you can indicate these other attributes also, but it is needed to have the primary key of student entity and the course entity for this composite entity. Okay, so but when we consider about the student and the course, okay, course can have that means you can see a course without any student. You can see that means course can have student as well as haven't any student. That means course can, you can see some courses without any students. So this course or a class is optional for this. That means student is optional for this course. So we can denote it like this. So in this case, this is relationship with, this is the relationship. Now at that time we denote it like this in this place. Okay, right. You can see this one. Student class. Now student can make many enrollment. When we consider about class, there are so many enrollment. So this is one to many and this is many to many. When we consider about a class, class can be a class without any students. So it can be denoted by using this optional mark. So when we consider about enrollment key, it is this enrollment entity. This consists with primary key of student as well as primary key of class. This one. Okay. Is it clear now? Is it clear? Concept. I'm talking about concept. Is it clear?
Yes, ma'am.
Okay.
Yes.
Okay. Then let's discuss. That's all about entity relational model. Again, we are going to discuss about ER diagrams in upcoming lectures. I think it is available in 13th or 12th session, 12th lesson. Again, we are going to discuss all these things in one diagram. Now we already discussed about components of the ER diagrams, then the relationships and the keys and the composite. Likewise, there are so many things. Again, we discussed all these things in the ER diagram under the lesson number 12, developing an ER diagram. I think we can start that lesson in next day. Again, we move into logical structure. That means logical structure of relational model. This is about entity relational model. Now we are moving to the relational model. When we consider about the relational model, what is the data structure of the relational data model? What is the basic data structure of relational data model? We discussed it in last week. What is the basic data structure in this relational model. What is the basic structure?
Table.
Implement.
Table. Table is the basic structure. So in this lesson, we are going to discuss about the tables, simply tables. Okay. Before that, in a relational design begins by defining the required entities, and you might recall it from the lesson. Okay. That the entity is simply person, place, event, or a thing for which we intended to collect the data. As an example, again, XYZ database. In this, this is session number 9. So in this case, university database is consist with the faculty members, students, and the courses. All these belongs to the entities. So when we consider about the entity has several characteristics. These characteristics are known as attributes. Okay. As an example, a student has a name and the number and the GPA, courses enrolled, date of birth. All these are belongs to the attributes of the student entity. Okay. So okay, we can denote this student entity like this to indicate this DOB belongs to student class, student entity. I already told this one. So the group in a related entity becomes entities become entity sets. As an example, student is an entity set which describes the group of a student. Each student in this entity is a set is and the entity organizer. This is also we discussed. When we consider about entity like student, this represents the set of students, not a single value. This represents set of employee in students. So when we consider about employee, this represent the entity sets. That means set of employees. Okay. This is about ER diagram or an entity relational model. In that case, we discuss about the entities and the attributes. Now we are going to discuss about the relational model. In relational model, we are going to discuss about the tables and the characteristics. Okay. ER model is belongs to ER. Yeah, ER design. That means ER diagram is from. Yeah, ER diagram is belongs to ER data model. Now, when we consider about this logical view of the relational database, it is facilitated by the creation of data relationship based on the logical construct known as table. So the basic data structure of the relational model is a table. We can say this table as a relation. Okay. So this table store all the entity occurrence of a given entity set. That is the term of entity sets, and the tables are often used to interchangeably. So the table is also called, I already discussed this one. Table is known as a relation. Okay. Before this one, this is a summarization of a table. When we consider about a table is consist with rows and the columns. We use rows to denote the characteristics of an entity. So this is known as a column name. So this define the characteristics. This define the tuples or a records. That means set of value for the given attributes. Okay. You can see this is an example for the table. So this is a student table. That means this is created for student entity with respect to the student entity in the AR model. Sorry, ER model. You can see. Okay. So how many attributes in this column? Sorry, in this table. How many attributes in this table? Can someone answer my question?
Six.
Sorry, this is same table. Okay, this is the same table. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is the same table. So there are 12 attributes in this table, not 6. Okay, this is same one like this, so it is difficult to denote in the slide system. Then how many tuples in this table?
8.
8 tuples. So okay, when we consider about the table, there are 8 tuples in the table and the 12 attributes in the student table. So when we consider about a column, this column represents an attribute. Each column has a distinction value. You can see this is the column name, student first name, student initial, student database. And what is the primary key of this table? Identify the primary key. What is the primary key? Sorry, what is the primary key?
Student number.
Student number is the primary key of this table. Okay. So when we consider about these rows, you can see this rows describe the value set for the given attribute. So this is when we consider about row, this is when we consider about the row, this row describes the value set for the attributes of a particular entity. So you can see when we consider about the 321452 student number, it is belongs to the Soisa C Mala Soisa. This is the date of birth, and this is the student hours. This is the student's class. Likewise, this is the GPA of this Mala. Likewise, so this one tuple describes the characteristics of a particular person or a particular instance of an entity. Now, entity එකක් කියලා ගත්ත student ගේ මාලා කියන්නේ එක instance එකක්. කියන්නේ මොකක් හරි එක occurrence එකක්. So when we consider about this record is describe one instance from a particular entity. So you can see this in ER diagram. We only discuss about this attribute names and the primary key attributes name and the student. In this case, we discuss about the entities and the attributes and the records also. So these are the set of domains or a set of values that can be available for each and every characteristics or the attributes. So you can see there are numeric values and the character value, that means text values, and sometimes this is the date value, and sometimes decimal values. You can see decimal value. All these can be taken as a record. Again, there are so many data types available in this table. So you can see each row and column intersection contain a single data value. So column and a row intersection point represent a data value. This data value can be with different data types. So these are some data types available in the database. Numeric value. This numeric value represent the numbers. As an example, you can see student GPA. This is a numeric value. And telephone number. It is also a numeric value. Then the characters. Text data or a string data belongs to this character type as example. So identify the character data types. Which fields belongs to character data type? No one in the class?
Student initial.
Yeah. Initial, student name, student last name, and the first name, they are belongs to character data type. Okay. Then there is another data type as a date. Okay. In this data types, we used special data format called as a Julian data format. In this Julian data format, they allows to perform any special kind of arithmetic for the date. That means if the database have if the database has a date of birth of a particular person, we can perform arithmetic calculation to find the age of that student. So you can see date is a date data type where this Boolean data format is mostly used for this date. Okay, you can see what is belongs to data, sorry, date data type. What is the attribute belongs to date data type? Identify. What is the attribute?
Is birth.
Date of birth, STD, DOB. Okay. So then there is another data type as a logical. In this data type, it can have, that means it can have two values as a true or false. This year or yes or no. That means as an example is a student is a junior college transfer. This is definitely yes or no. So we can use this yes or no to store the data as a logical data types in the database. Then about primary key, we discuss about the primary key also. Okay, so identify this logical data types. Which field holds the logical data type, or which attributes hold the logical data type?
Students transfer.
Yeah, student transfer. Okay, I think now you can identify the data types as well. Then let's move into this primary key. We already discussed about primary key. This is a key which is used to identify each and every record. So it is needed to have. So when we consider about a primary key, no duplication value can be available. That means no duplication values in the primary key. So then let's discuss about entity integrity. So when we consider about the entity integrity describe about the primary keys. Okay, the primary key must be a unique and it will uniquely identify the each row. In this case, table is to exist. That means table is said to exist in entity integrity, and also it is needed to have, that means it is, and also it, that means primary key not allows to have null values for their data set. Okay, so entity integrity means, simply this entity integrity means, you can see if you, when you are choosing a primary key for a table, you can choose a attribute without having null values as well as duplication values. So you need to consider about null values and also duplicate values when choosing a primary key. This primary key not allows to have duplicate values and the null values. This is known as the entity integrity. Okay, is it clear?
Yes, madam.
Okay, so the null value can be an unknown attribute value or a missing value or a not applicable value. So you can see there are some null values in the table. When we consider about this one, this one, no values, so null values. You can have some null values in a table, but it is when you are choosing a primary key, this primary key not allows to have null values as well as duplication values. Okay. Then the values in the column match entities character, for example. Okay. So
Madam, most of the table you show.
yeah.
Most of the table you show this session and previous session, I could Identify that the primary key field is numeric key. Is it a must or other field, other data type also we can use?
We can use anything. Most probably it's a numeric value because we can use the numeric values to identify each and every records uniquely. Sometimes it can be a unique combination of number and a character, or sometimes it can be a character like this. You can take as an example, you can take a grade to identify each and every. So grading system is from G1 up to G26. So G1, G2, G3. Likewise, you can take character values. So you can take character fields as a primary key. That's up to you. No need to take numeric values. And sometimes you can see student number S1, 2, 5, 3. This is a character. This is belongs to character. Okay, likewise, that's up to you. Then, yeah. So the column range of the permissible value is known as the domain. You can see when we consider about this attribute. Wait. Yes, that table. You can see when we consider about this column, this is the student last name. So this is the domain of this attribute. Okay. This is the domain of this attribute. So this is the domain of this attribute. When we consider about the GPA, maximum value for the domain is equal to 4 and the minimum value of the domain is equal to 0. So all these values are between this range. Okay. Dilhani, do you have any question? Okay. Then, okay, this is about main concept about tables. I think now you can identify what are the characters, what is the table name, what is the primary key, what are the attributes. Now you can identify the domain set and the data types of each and every attributes, and also you have some idea about how to represent the attribute name. So these are the tuples, these are the attributes. You can see the data set. This data set is known as a domain of this characteristics or attribute. So this is all about tables. Then let's discuss about the keys in the tables. You already have some idea about the primary key. Okay. So primary key is used to identify or to control the data redundancy or a data duplication. Okay. If a table in a relational database shares a common attributes, we can link the table rather than combining two tables. So when we consider about a table, no need to put your student number and the names into the chat. So when we consider about a table in the relational database, so in the database, when we consider about the database, it can have more. So it can has more than one tables. Okay. So it can share a common attribute. We can link the table rather than combining two tables. As an example, you can see these two tables. Okay. This is the student ID. This is a student table and this is the student combination, that means subject combination table. There are two tables as a student and the subject combination. In this case, you can see this table consists with this attribute and also this table also this attribute. So the same attribute within two tables. So at that time, we are not going to combine these two tables into one table. We are going to create a link between these two tables. Okay. This kind of, in this case, this kind of cases, there are two tables with the same common attribute. At that time, we are not going to join them. We are going to create a link between these two tables. You can see This is about student ID, student name, student combination. This student combination is from this table. When we consider about the student combination table, it is consists with the student combination ID. This is also available in student table. Then the combination name, number of the student, and the department. So when we consider about Sunil, so what is the subject combination of the Sunil, and what is the department that Sunil belongs to? Question: what is the subject combination? What, give the subject combination name of the Sunil. What is the subject combination of the Sunil?
CSE, static maths.
Maths. So what is the department he is belongs? Which department he is belongs?
Computer.
Computer department. So you can see there is a link between these two tables. So Sunil, first you can find the subject combination is S001. Then you can move into this table S001. This is the subject combination. So this is the department which he is belongs. Okay. Then Hashan. I think Hashan 102256784. Hashan.
Yes, ma'am.
Okay. So what is the subject combination of the command?
S001.
Sorry, not a subject ID. I need the combination. That means combination name. What is the subject combination name of the command? Okay. Any other volunteers?
Same. CSE, static maths.
Maths.
Okay. Likewise, you can create a link between these two tables and you can use this link to identify the data available within two tables. Okay. Then you can see we can create a link. This is known as a relational schema. Okay. We are going in your that means in your textbook, this is not available about the relational schema. I'm going to discuss the relational schema before starting the database normalization. So this is known as a relational schema. You can see this is the student table. This is the subject combination table. These are the attributes available in the student table. You can represent it using a rectangle shape, linked rectangles like this you can use. So this is the primary key. This is the student name and the student combination. So there is another table like subject combination. Subject combination ID is the primary key, combination name and the number of IDs. So you can see this is the common attribute and there is a link between these two like this. In this table, when I'm asking question from you, you use these numbers to find the combination and the department. So this relationship is from this table to this one. Okay, you can denote this relationship like by using this arrow. Right, this arrow. So you can create a relationship between this. So this is the relational schema. So relational schema is relation means tables. No? So this relational schema represents the relationship between the tables. You can see student and the student combination. Student subject combination ID of the student has a relationship to the student, has a link to the subject combination ID from the subject combination table. You can create a schema like this. Okay. Then let's discuss about foreign key. We already discussed about primary key. Now we are going to discuss about a foreign key. You can see when we consider about a primary key is a sum. When we consider about a primary key, this is the primary key of this table. This is the primary key of this table. So you can see this one. This subject combination. So this subject combination attribute is really belongs to this table. Okay, so when we consider about the subject combination, it is belongs to this table, but it is available in this table also. Such kind of tables, that such kind of keys are known as primary key. The foreign key is an attribute in the relational database that provides the link between two tables is known as a foreign key. That means foreign key is a field in one table that refers to a primary key in another table. Okay, simply the foreign key is a field which available in a one table and refers to a primary key in another table. So this is the foreign key of this table, but it is a primary key of this table. Okay. The foreign key is a field in one table that uniquely identify the rows in another table. Okay, now I'm going to give you an example. There are two tables like this. So what is the primary key of this table? So when we consider about the table employee, what is the primary key?
Employee ID.
Employee ID. When we consider about the department table name is department. Primary key of the table, department table, what is the primary key?
Department ID.
Department ID. Is there any primary key of these two tables? Oh, sorry, foreign key. Is there any foreign?
Yes, department ID is
Yeah.
foreign key of the
Which table? This one. I'm going to write the foreign key in this place or this place. Which one?
above table has a foreign key.
First time.
Foreign key is department ID. So we can create a link between these two. So the foreign key is in a one table is definitely a primary key in another table. I think it was clear now. Then let's discuss about the referential integrity. In the first case, we discussed about the entity integrity that is available with the primary key. When we consider about the referential, that means referential integrity. In this integrity means that if the foreign key contain a value, that value must refer to an existing valid tuple or row in a relation where it is originated. That means when we consider about this one, that means when we consider about this is the foreign key of this table. Now I'm going to erase this like this. So definitely this is the foreign key of student table. You can see SS01, SS05, SS01, SS02. So I'm going to insert SS03. Can I insert this value to this table? Sorry, S008. Can I insert S008 into this table? Can. Is it possible to insert this S008 into this table.
No, it's not possible because it's not in that
Yeah,
subject combination table is not there.
yeah. So we can only insert the values which are available in this table. So it's 008 is not available in this table. So it is not possible to insert this value into this table. So in this case, which table is needed to create first? This one or this one? As example, when we are going to create in these two tables, which one is needed to create first?
Combination.
Second table, subject combination.
Combination tables needed to construct first. After that, you can create this student tables. Okay, because this inserts some values. That means this is belongs to this tables. So this content only the values available in this table. So it is needed to create this one first. Okay, I think it was clear now. Then this is about referential integrity. Then let's move into the determination. So the key is a device that helps to define the entity relationship. One type of key known as a primary key has already been introduced. The key's role based on the concept of determination. In the database context, you can see the statement A determines B. That means A determines B means the value of the attribute A, you can look or determine the value of B. That means value of the attribute A, you can look up the value of the attribute B. As an example, you can see this is the shorthand notation of the determines. A determines B. A determines B. So as an example, you can see this student ID in the student table. So by using this student ID, we can determine the student table. So we can use student ID to determine the student table. So student ID determines the student name. Is it clear? This is, we can use this student ID to determine the student name. Is it clear? Because this is a unique value, this is the primary key. So by using the primary key, we can determine the value of other fields. So this student ID can be determined student names. Okay. So this can be a one attribute or more than one attribute. In this case, student ID determines the student name. So again, you can use student ID to determine the student name as such as student as well as student combination ID. You can see by using this student ID, you can determine the student name as well as the student combination ID. Is it clear? Determination means the key's role. Okay, so using the primary key, you can determine any other attributes. So in this, according to our example, by using the student ID, we can determine the student name. Is it clear? It is a simple thing. Is it clear?
Yes, ma'am.
Okay, when we consider about this determination, we can divide this determination into two that means two categories, the functional dependence and the fully functional dependence. So you can see the principle of the determination is very important because it is used to definition of a key reference, that means key relation database concept known as a functional dependence. So when we consider about functional dependence, we can define the most easily way is the attribute B is functionally depend on the attribute A if A determines B. So as according to our example, student ID, then let's take a student name. You can see this student name functionally depend on this student ID if this student ID determines this student name. Okay. According to this example, this is the primary key employee number. You can see employee number can determine. That means employee number determines employee first name, then the last name, and the employee phone number and the employee age. So this employee name is that means functional dependence on this employee number. Employee number is functional dependent. Sorry, employee phone number is done. Phone number is functional depend on employee number. So you can say employee last name is functional depend on this employee number. Employee age is functional depend on this employee number. Is it clear?
Yes, madam.
Okay. So you can see in this is when consider about functional, when consider about primary key, you can see there are two types of primary key, the primary key and the composite key. So in the composite key, you can see example like this. Employee, yeah. When we consider about all these three attributes get together to determine this employee number. So this is a composite key. At that time, we can say this employee number is full functional depend on these three attributes or this composite key. Let's take another example like this. Course ID and the department ID. This is C21, this is D11, D name. When we consider about this table, this is the primary key. This is the composite key, course ID and the department ID. So these two determines this department name. So you can say department number name is fully, that means full functional depends on these two attributes. Is it clear? In the primary case, yeah. I'm going to take this one. Let's take like this. A. 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 This is the primary key, this is the primary key. Okay. So A determines C and D. So D functional depends on A. Is it clear? A can determine C and D. At that time, we can say D is functional depend on A. Is it clear? Is it clear?
Yes, madam.
Okay, so you can see this one, C, D, and E. This C, D, A and B get together to determine. That means A and B determines C, D, and the E. So A and B can determine C. So when we consider about this, not C, let's take again D. A and B determines D. So when we consider about this D is full functional depends on A and B. Is it clear now? In this case, one attribute. In this case, two attributes. In the more than one attribute. When we consider about a composite key, at that time, full functional dependence. In this time, functional dependence. Is it clear now?
Yes, madam.
Yes, madam.
Then let's move into the super key. So super key is a key that identifies each entity uniquely. In short, the super key functionally determines all the entities attributes. So you can see super key is just like the primary key. This can be used as a super key, or you can take a combination of employee number and the employee last name as a super key, employee number, last name, and the name as the super key. Super key is a key which used to identify each entity uniquely. Super key can be a primary key or any combination with the primary key. Then the candidate key, we already discussed about the candidate key, the key that is qualified to become a primary key, but designer not selected as a primary key. Such kind of keys are known as a candidate key. In our previous example, you can see NIC and the employee number. Both are qualified to become primary key, but designer only use this designer use employee ID as a primary key. So NIC is a candidate key. Okay, then the secondary key. When we consider about the secondary key, already discussed about primary key, candidate key, and the super key. Then secondary key. When we consider about a secondary key, is defined to key that is used strictly for the data retrieval process. So when we consider about a database, we can insert data into the database and also we can retrieve the data from the database. So this secondary key is used to retrieve the data from the database. As an example, you can see this student ID. So not this student ID, let's take customer ID and the customer name. So ID is equal to 0001 to 5, name is equal to comma. So at that time, do you think the most customer will remember their customer ID? Definitely not. So at that time, you can use this last name to find this customer within the database. So therefore, this kind of attributes are known as secondary keys. So data retrieval purpose, we can use some familiar attribute rather than using a primary key. So this familiar attribute is known as a secondary key. Okay. These are some examples. You can go through this example. When you consider about a customer, you can use customer phone number to retrieve the information. Definitely customer remember his or her phone number. No? So you can use this customer's phone number to retrieve the data from the database. At that time, customer ID is the primary key, but we can use the secondary key to retrieve the data from the database. Such kind of keys are known as secondary keys. Okay. Then the integrity rules. So we discuss about two integrity. The first one is entity integrity available with the primary key. Then the referential integrity with the foreign key. Foreign key does not allow to have any values which does not available in the table which it is belong as a primary key. So it is known as a referential integrity. Okay. Then you can see this one. This is the summarization of two tables. This is the entity. Yeah, again the same thing. You can see this is the summarization of a database, CH insurance CO database. Customer ID is the customer is the, there are two tables, customer and the agent. You can see primary key of the customer table is equal to cus code and the primary key of the agent table is equal to agent code. Sorry, agent code. When we consider about the foreign key, this is the foreign key agent code. So this is refers to the primary key of this table. So you can see there are no any duplication values for this primary key and no null values. So in it integrity is there. When we consider about agent code, no any duplication and no null values. So you can see entity integrity is there. So when we consider about referential integrity, you can see 1, 2, 3 or 501, 502, 503. All these records have these three values only, but there is a null value. When we consider about a foreign key, it can have, so it can has null values. No need to have a value. It can be a null value. So this is a consist with referential integrity. Okay. So you can go through this one, this slides. This is about the description of these two tables. So no need to repeat it again and again. You can see that now in this database, you can see this is a null value. So it is very difficult to handle with the null values for a numeric field. So this is a numeric field. So it is difficult to handle this null value. So at that time, the database user. So when you are querying this database, that means when you are perform any arithmetic operation with this or any calculation with this database, it is difficult to handle this null value. So we can use the dummy value as a null value. At that time, we can assign a dummy value like minus 99 or minus 110 or any dummy value to represent the null values in the database. At that time, this dummy value is known as a flag. Okay, this is done by the database designers. This database designer uses a dummy or a flag, dummy value or a flag to indicate the null values within the database. So when you are seeing, that means when you are referring your database or any other database, if there are any field with minus 99 or minus 999 minus or likewise, you can easily identify it belongs to a null value. Okay, so that's all about relational model. Are there any questions or do you have any questions? This is the session number, that means lesson number 9. Do you have any questions? Okay, secondary key means, as an example, you can see the customer table. So the customer table, it is consist with customer ID and the customer name and the customer address and the customer table. So when we consider about the DBMS, we use some queries. Still we are in database designing phase. Okay, after design, after inserting data, so we are going to calculate some arithmetic performance on this table. So at that time, we need to retrieve data from the database. That means we want to get the data from the database. At that time, we can use some fields to retrieve data from the database. So when we consider about customer, do you think any customer can identify or can remember his customer ID? Sometimes we forget our national identity card number also. So when we consider about this ID, it is not familiar with us. So this is the primary key. At that time, we can use any secondary key to retrieve the data from the database. So definitely customer can remember his phone number. So we can use the phone number to retrieve the data from the database. So phone number acts as a secondary key for this database. Is it clear now? Prashni, is it clear? දැන් අපි හිතන්නේ primary key එකක් තියෙනවා. හරි. primary key එකක් තියෙනවා. හැබැයි primary key එක customer ID එකක් වගේ නම් customer ට ඇත්තටම customer ID එක මතක නැහැ. ඇත්තටම අපිට සමහරවිට අපේ identity card number එක අමතක වෙනවා. අපි student number එක අමතක වෙනවානේ. ඒක නම් හොඳට පේනවා ඔයාලගේ papers බලද්දි student numbers මාරු කරලා ලියලා තියෙනවා. එහෙම. ඒතර ඔයාලගේ student number එක අමතක වෙනවානේ. ඒ නිසා අන්න ඒ වගේ වෙලාවට දැන් අපි customer ගේ customer ID එක පාවිච්චි කරලා එයාගේ data ගන්න බෑනේ. අන්න ඒ නිසා එයාට familiar මොකක් හරි එකක් secondary key එකක් විදිහට පාවිච්චි කරනවා. ඔයාලා ඔක්කොටම ඔයාලගේ phone number එක මතකයි මොන අමතක වුණත් ඒ නිසා අපිට පුළුවන් customer table එකේ customer ගේ phone number එක secondary key එකක් විදිහට පාවිච්චි කරන්න. අපිට familiar data retrieve කරන්න use කරන key එක තමයි secondary key එකක් කියලා කියන්නේ. The key which is familiar for us and we can use that key to retrieve the information from the database. Such kind of keys are known as secondary keys. Okay, then let's move into our next one. It is about relational algebra. Still we are in relational database mode. Okay, relational algebra. In our previous lesson, I told that the database, that means database operation or arithmetic operations done on the databases. So you can see When we consider about a relational database, we can use operators to manipulate and control the tables. So definitely tables are consist with data. So you can use any operators to perform the any arithmetic. Give me 1 second. Okay. So when we consider about a table, we can perform or we can manipulate the data available in the table as we can control the data. To do these things, we need some relational operators. Okay. As an example, if you need to wait. Can you all see my screen? Can you all see my screen?
Yes, madam.
As an example, let's take a table like this. So customer ID and the name. So C001, C02, and there are some other attributes. I need to find the customer C002. Okay, so at that time we can use any operators to perform the calculation available on this database. So at that time we can use some relational algebra to manipulate and control the tables content. So these are the main 8 operators available in relational database: select, project, join, intersect, union, difference, and product, and the dividers. Okay, in this lesson, we only discuss about the functionality of this state, that means functionality of these operators. After discuss about the, which one? SQL, that means database manipulate language, that means structured query language. Let's discuss, after we will discuss about how to perform the, how to perform these operators, that means relational algebra on the data set or a database. So the SQL commands can be used to accomplish the relational algebraic task. Okay, so these are going to discuss after learn about SQL. That means after the session, I think this is available an introduction to. That means after the lesson 14. Okay, so you can see there are 8 operators. Let's discuss one by one in detail. In this lesson, we only discuss about the functionality, not about how to perform these operators or how to perform the algebraic task. Only discussed in this lesson. Only discussed about the functionality of these operators. The first one is union operators. So we can use this union operators to දැන් මෙහෙම අපි මේක ඔපරේටර්ස් ගැන කොහොමද මේක SQL එකත් එක්ක apply වෙන්නේ කියලා අපි SQL කරාට පස්සේ කියන හැබැයි මේක තමයි basic එක. ඔයාලා දැනගන්න ඕනේ union operator එකකින් මොකද්ද වෙන්නේ කියලා. So when we consider about a union operator, we can use this union operator to combine all the rows of 2 tables to combine by using the same attribute characteristics for all columns. That is the number of columns and their domain must be identical. In this case, you can see there are 2 tables, not a 2 table. This is also a table. You can see there are 2 tables. This is the product tables and the added product table. So we are going to perform the union operator on these 2 tables. That means product union, added product. To perform this one, it is needed to have the same number of columns for both table and also the same column name. So you can see same column names, number of columns are equal to 3 in this table, number of columns are available in this table is equal to 3. Now we are going to There are two conditions. Number of columns should be equal, and the number, that means character's name, that means attributes name, should be equal. So these two tables achieve these two conditions. After that, we can perform a product union added product operation. At that time, this operation produce the another table or a new table with same field or a same attributes, but it contained all the details from two tables. So you can see this table consists with 1, 2, 3, 4, 5, 6 records. In this table, 2 records. So after performing the union operator, you can see a table with this 8 records. 6 plus 2 is equal to 8. 8 records. So you can use union operator to combine two tables with the same characteristics. Is it clear? Is it?
Yes.
Okay.
Yes,
Madam.
Even next one, it is about intersect operator. So when we consider about the intersect operator, produce a listing that contain only 2 rows that appear in the both tables. Two tables must be union compatibility. So to do this intersect operators, it is needed to have a union compatibility. That means same number of fields with the same characteristic names. You can see same attribute name. So now we are going to perform the intersect operator for these two tables. This one table 1, table 1, T1 intersect T2. At that time, you can see this operator outputs the row values in both tables. That means same row values in the both tables. So when we consider about George, is it available in this table? George, this value is George value is available in this table.
No.
When we consider about Jane, yeah, it is
Yes.
this one. Elliot, no. Wilfried, no. When we consider about George, it is available in this table. So we consider about T intersect T2, there are two outputs as the John and the J, George and the J. So this output, that means intersect, provide the same row in the two tables. Okay. So to perform this one, the button attribute is a numeric and the one attribute, you cannot use this intersect if the one attribute is a numeric one and another attribute is a character one. So it is needed to have the same data type for both tables. Is it clear?
Yes, madam.
Then let's discuss about the difference. There are this is the third operator, difference operator. So in this case, need two tables as its operands and yields all rows in one table not found in a other table. This will output all the rows in one table that not found in the other table. So this is just like a subtraction. Okay. So you can subtract table 1 from the table 2. To do this one, it is needed to have union compatibility. Union means you can have same characteristics for the two tables. So you can see this is the table 1, this is the table 2. I'm going to perform the table 1, difference table 2. This is just like a table 1 subtract table 2. You can see Jane available in this one, William not, George. So you are going to out, that means this operator going to output the difference between these two. So you can see these are available with this table. So this operator output only George, Align and Wilfried. Okay, is it clear? The difference means you can subtract one table from another table. Okay, this is T1 difference T2. So can you tell me T2 difference T1? What is the output of T2 difference T1? Can someone answer my question? Can you tell me what is the output of T2 difference T1?
William and Dennis.
William and, sorry, I can't hear you clearly. William and who is the another guy?
William and Dennis.
Dennis, yeah. William and the Dennis. These two fields are available. Yeah, rows are available in this one. So the William and Dennis is the output of T2 difference T1. Okay. Then let's move into product. So in this case, this is just like a multiplication. So needs two table as its operand. It is already, this is the product operator and two tables as the operand, and the all possible pair of rows from the two tables. So the operand tables are not necessary to union compatible with each other. So this is known as a Cartesian product. You can see if you use 10 rows from one table and 20 rows from another table, this product output, that means T1 product, T2 output 10 into 20, that means 200 rows. You can see this is the product table and this is the, let's take this is as a store table. I'm going to find the product. So let's take this one as a T1 and this one as a T2. I'm going to find the T1 product. T2, this is just a Cartesian product. You can take this one, then this is going to be multiplied with this row and this row and this row. So all there are 3 records. Then let's take this one. It is going to be multiplied with this one, this one, this one, 3 records. Likewise, all these records are going to be multiplied with these 3 records. At that time, it will provide how many before that? How many records in this table?
6.
6. So this table?
3.
3. So what is the difference? What is the output of
18.
18 tuples.
18 tuples? You can see the 18 tuples. So difference table this is the difference table. Someone asked to show the difference table. You can see. I'm going to upload all the slides and the recordings for your Learn USS, so no need to worry about this. Then let's move into our next topic. It is about select operators. So this is the most widely used operator with the SQL, select operator. So in this select operator, it is used to select some values for the, that means it is used to find the yields value for all the rows found in the table. So you can use select operator to select rows from the database. It can be all rows or it can be a subset from the data set. It's up to you. So you can see when applying select operator for this table, in this case, you are going to select all the tuples from the original table. So at that time, this is the output. In this case, you are going to select the tuples only the price less than $2. So you can see when we consider about $2, there are 2 at tuples that the price less than the $2, this and this. So this is the output. In this case, you only select the tuples which are having P code is equal to this one. P code is only one record, only one tuples is there. So you can output it like this. This is about the select. Okay, then let's discuss about the project operator. So when we consider about a project operator, use a single table as its operand. All this or this case, we use two tables, but in the select operators, you can use one table or more than one table to perform the select operators. When we consider about this one, project operator only uses single table to perform this project operation. So in this case, it yields all the values for the selected attribute. That the project operator is the vertical subset of a table. So if you need to take the vertical subset, you can use the project operator. By using this project operator, you can take the vertical data set. So data description or a price or a project code you can take by using this project operator. Project feed the script and the price key. So at that time, this will output this column and this column only. Okay. I think it was clear. Then about the join operator. Okay. Do you have any other practical session at 1 p.m.? Yeah. Let's stop at 12:30. Is it okay? Okay. Let's stop at 12:30. Is it okay? Who is this? I don't know. Is it okay? Is it enough 30? Is it enough you do 30 minutes for having your lunch? In the class. Let's stop at 12:30, okay? Okay, then let's discuss about the join operators. When we consider about the join operators, allows us to combine the information from one tables and uses two tables having a common attribute as its operand. So the join operation is considered as a real power behind the relational database implementation. You can use independent tables linked by a common attributes, and the result is minimal redundancy possible. You can see there are so many joint operations. Joint, that means there are so many joint operators: natural joint, equijoint, theta joint, left outer joint, and the right outer joint. Let's discuss these things in details in upcoming lectures. Let's get some idea about natural joint. You can see we are going to join the customer and the agent table. In this case, these are the two tables, and to join these two tables, first you need to take the product of the two tables. So 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4. So you can find the product between these two tables first. Then you can select is performed on the step 1. That means in this table, you can perform the select operators to select. That means to yield only the row for which the joint column values are equal. After that, you can perform the project on the step 2 to yield a single copy of each attribute, and in that case they eliminate the duplicate columns. As an example, in this case there are two tables, so this is consist with 6 records, this is consist with 4 records. 6 into 4, 24. First they are going to perform the Cartesian product or a product operator on this two table. At that time you can see this kind of table. This can have any duplicate. When we consider about this one, you can see. Yeah, this is the product. 1, 2, 3, 4. There are 24 records in this table. So this is the Cartesian product of these two tables. Then you are going to select only the rows which your joint column values are equal. So in this case, you are going to find this 25. Agent font. What is the 125? No? So you are going to find this one. What is the joining? That means this joining attribute same. That means joining value same records. So you can see this one, and there are some others. This one and this one. Likewise, you can perform this one. Okay, you are going to find these four records. First, you need to find the product of these two tables. Then you are going to take the values, that means columns values are equals. You can find the rows which the columns values are equal. Then you are going to eliminate the duplicates value. Okay. In this case, you can see this column is, this is from the customer table, this is from the agent table, same column with the duplicate. So in the third step, you are going to remove one column from the table. Then you can see this is the output. Okay. In this case, join is going to find the matching values from the two tables or a joint value from the two tables. To do this, first you need to take the Cartesian product of the two tables. Then you can find the attributes with the same, that means you can find the records with the same value. After that, you can eliminate the duplicate columns. Okay. Then the divide operator. So when we consider about the divide operator, it is required to use one single column table and two column tables to perform the divided operator. One table should be consist with one column and the another table should be consist with two columns. So it is needed to have a one column table and a two column table. And the result, a value in the non-shared column must be associated with the every value in the dividing table. So you can see we are going to find, this is the T1, this is the T2. Now we are going to find the T1 divide T2. In this case, you can see A. This is the A. Okay. When we consider about B, these are the B. So when we consider about A is associated with 5 and 9. When we consider about the B is associated with 5 and 3. In the both case, you can see A is appeared. So the output is equal to A. The common values for both records in the table T2. That means this one. Table 1 is divided by table T2. The both values has the attribute code. Then the attribute LOC is not shared. So you can see the only value associated with both A and B is 5. So the output is 5. So I'm going to give you another example. This is T1, T2. Field 1, field 2. This is field. Kamal Sunil, then Namal, then Pereira, then again Kamal, then the Namal and the Sunil again. Okay, 1, 2, 1, 3, 5, 5, 3. So what is the output of T1 divided by T2? This is the table 1. It is consist with Kamal 1, Sunil 2, Namal 1, Pereira 3, Kamal again 5, Namal again 5, then the Amal 2. The T2 is Kamal and the Amal. So what is the output of T1 divided by T2? That means Ty divided T2. What is the output? Is it clear? What is the output? No one in the class. Hashini, what is the output? Can someone answer my question? What is the output of this T1 divided T2? Not 1. There are some other values. 5. 5. Then, yeah, 1 and the 5 is the output of T1 divided T2. Oh,
Both 1 and 5 are the answer, is it?
1 and the 5 are the answer. 1 and the 5 are the answer for the T1 divide T2. Okay. I think now we have some familiarity with this relational algebra. Our next lesson is about relational database model. Now it's already 12:20 and we have some practical session on 1 o'clock now. So let's stop for today. In next week, we are going to discuss about relational database as well as developing an ER diagram. This is for the third and the fourth. Okay, before your first CAT exam, let's try to finish the ER diagram. So please go through all the lectures, that means all the lecture note as well as the recording. If you have any doubt, you can ask them in next day. And in next day, we are going to develop in a ER diagrams. To develop the ER diagram, it is needed to have all these basic concepts. So please go through the lecture notes. Okay. So let's stop for today. Before that, do you have any questions? Do you have any question? You can answer. Can provide any answer, yes or no?
Oh,
Okay. If you don't have any question, let's madam, if you have any doubts, how can? Yeah, you can directly contact Govind sir. I think you have some in Learno USL. You can see under the contact information, you can see the contact details of the Govind sir, that means senior academic coordinator and the junior academic coordinator. Through that contacts, you can directly contact them. Okay. Then wind up for today. Thank you.
Thank you.
Thank you so much.
Thank you, madam.
Thank you, madam.
Thank you, madam.
Thank you so much, madam.
Thank you, ma'am.
Thank you, ma'am. Thank you, madam.
Yeah, next day is 3rd November. And there is another extra session on 4th also. Okay, I think no more questions. So let's find out.